busy and exciting agenda for everyone today, so let's roll them in. Okay, good morning, ladies and gentlemen. Welcome to the second day of Health Design 2024 at this fantastic Dibley Center here at Aalto. My name's Pat Halford. I have the pleasure of being your moderator for the day. We have a very exciting morning, kicking off with Sus, who I'll introduce in a minute. I keep getting these messages actually saying that my Jack Russell puppy, Sulu, is outside the garden perimeter in Kuopio somewhere. So my wife is working at the University of Eastern Finland. I hope she's getting the same messages. Actually, I just want to make a quick kind of comment based on what I observed yesterday at the pitching and the workshop. So one of the useful hacks that startups can actually use when they're investigating potential partnerships with VCs, or indeed universities if they're thinking about spinning out companies, is if you open up Google Notebook LN, and then you actually go to the website of the VC that you're considering partnering with, drag in their website into a new notebook, then drag in the LinkedIn profiles of all of the key partners, drag in the portfolio companies within their portfolio into this notebook. Maybe there's some white papers, some news items, some YouTubes. If you pull all of this together, then you can actually start interrogating that in a very interesting way and gathering a lot of good information about the funding, the successes, the focus of the VC partners. And that's actually a very good way of accelerating your activities, your discussions with potential funding partners. And of course, VCs can do the same for the companies or the startups that they're kind of investigating. So that's just a quick hack, worth trying. I can show anyone how to do that afterwards. So now we're going to kick off with this exciting agenda, and first up we're going to welcome Sis Zoffman-Glut to the stage, all the way from Aarhus. So I think, Sis, you're going to take it away and you're going to actually introduce your panelists, and then we're going to have a conversation. We hope there's going to be a lot of audience participation as well. So please, Sis.
Thank you very much, and thank you to Otto for inviting me here today. So already yesterday you heard a bit about needs-driven innovation, you will get another chance to hear about that today in my talk, and I'll try to twist it, the explanation of it in a bit different way. Do we have a clicker? Okay. Yeah. So in Denmark we have a needs-driven health innovation program, and we have 87 already trained fellows, innovation fellows in the needs-driven innovation process. And they are doing a lot of good stuff now in the Danish health technology ecosystem, and also out in the hospitals. And what is need-driven innovation? The simplest way to explain it is actually that I call it's the Einstein way. And many of you are maybe familiar with the expression that Einstein would, if he had 60 minutes to solve a problem, he would spend 55 minutes on understanding the problem, right? And then only 5 minutes on figuring out what the solution should be. And that is, to me, the core or the essence of needs-driven innovation is really to stay and explore the problem in a proper way for long enough time. So it is an approach where problems are identified and explored before we get hooked on what the solution should be. And now I've set problems in brackets here, and that's because the starting point for problems is not only going into the clinical departments and look at the work that they're doing there. You can actually have an input for the problem from many different sources. It could be from data, it could be from epidemiology, It could be from gaps in existing technology that are not, performing as we would actually like it to. So there are many. It could be the friction points that you see between people interacting with technology. So there are many sort of starting points, and the point is then that in order to stay in the problem, you need to go 360 degrees around understanding what is the problem and what is the context that the problem exists in order to really understand where is the solution space. And the Need-Driven Health Innovation Program in Biomedical Design in Denmark, we do also start in the clinic by spotting problems from observing the frictions between the healthcare professionals and the patients and all the technology that they interact with. And we then use that as a starting point to go 360 degrees around the problem and define and validate, okay, is there actually an unmet need here to get solved? And only then do we then start the ideation of what should be the solution to that gap. And also, we don't go forward with needs where we don't see that there is a, what you can say, that it's worth solving the need. And worth solving is both in terms of, okay, can we actually make it viable in the system afterwards? And we draw on a different set of methodologies during our program, so many of you might be familiar with design thinking, which is very much a human-centered approach to design new solutions. And then we use primary and secondary research to really ensure that we go 360 degrees around. We use the customer development principles, also known as the lean startup way. And in order to monitor the progression and development, we use the innovation readiness level scale developed by KTH. So I'll just jump to this. So how does it look like in real life? So here you see Christine up there there, that's Christine, and that's an innovation fellow that we had at one time. And she had been into a neonatal department and seen that the nurses and also the parents of neonates, they had a really sort of a cumbersome process of lifting the baby from the incubator and over to the mother to get this skin-skin contact. It's a nursing principle called NINCAP. There was a really, in some of the situations she saw that the intubations were displaced, and that then caused a whole set of troubles. So one thing is to see it. You also need to then go and talk with the people. Did I understand? Did I analyze the situation correctly? So have this interaction with the stakeholders in the problem is really important. And one of the ways that you can also have such a conversation is to first draw up the patient journey as you see it, because that forces your key stakeholders to actually also relate the problem that they are in to the surroundings, things that are going on before and after their own sort of role in the process. So that's one practical way of how it looks like in the needs-driven process. And then the next step, when you are ideating your solution, go out and interact with your users, show your ugly prototypes. And it's actually pretty important that you use exactly your very ugly prototypes, because then that stimulates that you can talk about other things than the idea itself. Because they will not, your stakeholder will not feel complied to tell that it's a good idea that you have, even though it isn't. So you can really talk about what are the requirements for any type of solution that you need to solve this problem. So just go out and show your ugly prototypes to get a proper feedback and really figure out what are the requirements for a solution here. And then don't underestimate the value of digging desktop research and also calculate health economics, because sometimes health economic calculation can actually show you the pathway that will make your business case a viable case, but also instruct what is it actually that you need to innovate. So in the case here of Christine, it was actually the health economic calculations that showed her that where she had to put focus was onto how to fixate the intubations of neonates, and to ensure that displacements would not happen when they were moving and lifting the child out of the incubator. So stay open to where what data input can actually inform you what is the case of what you're innovating on. Yeah, and that can then end up in a solution which is on its way to the market now, that are ensuring that intubations will not displace, and because every time it displaces, it causes that the child has to stay 14 days extra in the neonatal department, which is pretty costly. Yeah, so that was all from me, and now we will proceed to Leo, and I will have a really big challenge here to express or to pronounce the Finnish names, but I will do my best. So Leo Karppinen from University of Eastern Finland, and you will enlighten us on AI in health innovation?
Yes.
Yeah.
Okay, yeah. I will talk about what you really have and you didn't know before. So this is when I have been facing when building some AI application for healthcare. And I will actually, without further ado, I ask you some questions about this thing. The setting is that some things can go wrong in the system. There are some kind of examples of it here. So how would I say? The first one is that you take in an anonymized X-ray data, you take the metadata out so that you actually cannot identify which persons they are. Because that is kind of one of the GDPR requirements on the system when you work with the data. And then you randomly select people from training and validation and testing. And then you randomly, okay, now it's better. And then you randomly select the kind of the training, validation, and test. It's of course making sure that none of the images are kind of twice or are actually duplicated in any of these data sets, so that they are totally separate. And then you train your model with the data. And then the question is that what goes wrong? There's another question that I could ask about. So again, if you go and take ICU, internal care, kind of intensive care unit data, and then you actually take the kind of previous examples of how people have been kind of gone there and whether they have survived or not, and then on that data you actually figure out the model that predicts survivability. Okay, then I again ask about what goes wrong. And then the final question I have that you can ponder, so that if you use the EU data pack on cancer images, collecting this kind of that you can actually give your own data for EU data pack for cancer research, and then this is okay for people because you have giving a kind of, let's say, commit. You actually give it kind of an agree that it can be used for research purposes or even for clinical purposes. And then I ask again what is going wrong. Okay, so I'm not going to make this easy. So I'm not going to explain these things. I don't have time for that. But you can actually come and discuss with me after the talk. And some hints about that is actually the talk I give. I'm really that person. So let's talk about this. I always like these things that people are starting from the beginning. For example, what happens in the classical times. So this is now the beginning of intelligence, believe it or not. So it's a trichopath. It's this kind of funny animal that has only 6 type of, let's say, cells on it. And it has no nervous system, it has no muscles, but then it actually still behaves in a consistent manner. It can actually hunt for food, it eats microbes, it can move around, and it can also escape things. Now the question is how it does it. And the funny thing how it does it is that even if it has no neural networks in it whatsoever, so this is like Bayesian system doesn't use neural networks, so it uses the pressure between the cells. And the pressure between the cells when they are putting together, they actually tune the frequency of the cilia, that they make them move. And there's a coherence ruling about how you do that, how you react to the pressure, and then they can do all this movement. Just from the information that they can actually are then using that. So it is a let's say, neural network person that still has an intelligence. So this happens something like, let's say, a long, long time ago. It's still alive, actually, you can find it from the nature. So this is how it works. So it can actually walk. So it's really thin animal on one system and has this little cilia, and they actually are coordinating, so they are not moving randomly in the setting. Okay, so there is perhaps another system, and this is the kind of a first event of having, which we know that is about artificial intelligence. It is the Antikythera mechanism. It is actually predicting the kind of movements of the planets. That does it actually pretty well. So it really gives you the right answers. So, and it is about this kind of 2,000 years on the facts. So we are not actually dealing with new things here. So intelligence is pretty old. And then let's define AI a little, because even the EU Act is defining intelligence, but I actually don't believe those definitions. They are really, really bad, and they are very many of those, and they are not really restricted. But I can actually say what they do. It's funny. No access to Microsoft. Let's go forward. So it actually, what we know about intelligence is complex. I think that everybody agrees, so it's an assumption. And then we can say that if you have artificial intelligence, then somehow you have to actually do kind of this. You have to believe that complexity can be created from simple steps. Because that's a requirement for artificial intelligence, because the computers are really dumb. So the only thing they can do is in a really Finnish way of setting. If somebody says something, you are going to be silent. So then if nobody says something, then you can speak. So that's a rule of a SSC, an OR gate, that is enough of actually defining all the functions of the computer. And they have even done computers that only have this gate in the system. So it's really, really simple system, and you can actually do everything that computer does using this also. And then there is this kind of epistemological question in a way. Is it really so that complexity can, in all cases, can be created with these simple rules? I have some example where intelligence is created by simple rules. So there is an example about murmuring birds here. So they have 3 rules. They are really also very kind of a human in the setting. Don't bump into others. I guess this is also kind of understandable. Then they want to follow where everybody else is going. That's also very humane. And then they want to be in the center. So these are the 3 rules what these guys are using. And then the follow-up of these 2 rules that are totally simple, totally understandable, is actually very complex behavior. And that complex behavior is the idea of avoiding fox. Because they are having such a funny movement that the fox cannot follow and they become predator. So even with really, really simple rules, you can actually get a really, really complicated behavior. So this is about swarm intelligence, essentially. I have also an example about swarm stupidity. Let me turn this one out. So So this is a set of cars that people have asked them to actually drive in a constant speed around a circle. And then you follow them a little time, like that, then what happens with this storm, kind of swarm stupidity, you actually start seeing a rush hour. There's going to be a shock wave that is propagating at 20 kilometers an hour in the back direction of the system. And that is what happens with human traffic as well. On other human, this is actually a human experiment that's happening sometimes. If one actually put a couple of self-driving cars in, they know how to actually do this happening. So this is a kind of, okay, this I talked about already. So then the other things about this kind of a, let's say, let's go too fast. That's this image. So this is now showing about some of these large language models. Oh, I can still keep it here, okay. Now, I promise you, I follow the rules. I'm going to be kind of a good person. So here you can actually see funny things about what happens when you are increasing the number of let's say, rules in the system. So, and you can see the number of rules now in terms of US, I guess billions is a billiard in our language. So what happens on those that if you increase the number of rules, essentially the system is the same, it actually gains in capabilities. This is called immersions in way. So just kind of copying it again and again. And now I think that some of this evidence is convincing you that with simple systems we can create complexity. Also to the level of intelligence. What else? So it comes here about, I would talk about legislation. So I was in this high-level expert group on AI, or EU rules that started to develop this kind of some of them. And it had these 4 principles, they are also in the Act. So one of them is the idea about human autonomy, one is fairness, and one is prevention of harm and explicability. So I'm talking about those ones that are actually on the right side about what is the meaning of those. So really often you have these principles that are our values, how we want to actually behave with the system, and then there's a question about why would be this, and then they are these kind of requirements that actually think about what we would do it technically or procedurally in order to kind of make the system having those values that we have. And there are lots of these kind of requirements sitting around here, and there are implementation that has to be technical or procedural. And very often it is not. Even if you had a very, very good kind of a technical system on cybersecurity, in a way that it is very little secure, then you have to make sure that if somebody calls you and says, I'm from the IT department, I would like to have your passport to actually do something with the data. So this is not going to technical. The technical system it doesn't go away. So you really have to have this procedural part of the system of making these things that actually have to work together. So it's not only about solving technical problems, it's also about how you do this. Okay, here is kind of some examples about when you are setting this up in the way why you need some of these systems on it. So for example, you want to have a behavior that is predictable to a certain extent on those tools. And predictability means that you drive in the traffic in such a way that people understand it. It's not enough that you follow the traffic rules. And that's about ethics of the system. And this is now a simulation for traffic, let's say, crossing, done by Texas University at some stage. And they are thinking about you doesn't need, if the cars are intelligent and they are self-driving, they don't need this kind of red lights at all. Actually, just go around here, drive, and then drive through the system with long speed and the system, and that will solve the problem. The problem with this one is that there would be no humans in that traffic. It's almost impossible. It's almost everywhere. I have an example that works. Here is an example that actually would work. So sometimes people do that. Actually, it's slow. Okay, let's look at a little about this part about human intelligence then. And this is saying all about human intelligence. There is a task on you. So which one is different on every one of these spots? And you find out that you think about the ones that are on the left side. So what's different there? So raise your hand if you figure it out. Oh, there's somebody done it. Oh, great. And then I can tell it. So it is the middle ones are different because the other one is in a different direction, the other one has another color. Okay, have you found the difference in the last one? Oh, There are lots of people doing that as well, and that's cool, that's really great. But if you see, it's actually much harder to find out. There's a difference in the setting that these two are coming with intuition. They are happening with our subconscious level. We have used kind of capabilities of selecting that one. And the last one is actually using kind of, let's say, serial thinking. Our kind of, let's say, the part that is conscious, not subconscious. Okay, machines work the same way. Data science is unconscious part. They find out the figure. Scientists, they find out the features. Deep learning, or us, we are finding the features by intuition. And then we do the reasoning on top of it. And now the question is that some problems that we have in our hands do require so many rules. For example, the cat detection requires about 1 million rules in order to figure out. You cannot just write them down. You cannot find them in your head if you think about whether I will find those things out. So that's impossible. So it's just the mere size of the rules. I said that if you have millions of rules, you can do some fancy thing as well. So this is what happens very often. And that is why deep learning is so important in a way, because it can access this kind of subconscious part of features that we have in our head. We are using on this every day. So let's see kind of some features about it. Here is a self-supervised learning, and here is a way that if you train it in an unsupervised way, so this is how transformers, I talk about more about that, how they are working. So that's the funny part on it. So they are self-supervised in a way that they only predict the next one, for example, or the useful data. I will show what kind of things happen. Yes. Oh, yes. The settings, so it doesn't take the sound out. But here's about transparency. So that's the deep learning model, in all of its complexity. This is what the first layer does. That part of the system divides the data with lines like that. They are decision boundaries. Then that's about 10 lines you need to classify the data that you have here. And then this is the next layer. That's our decision boundaries. These are the features that come in with the next layer. And you can see all these things. People are claiming that this is a black box. And I will see that doesn't look like a black box to me. Then if you say, these are the next layers, what comes out in, these are the features that you are using for classification. And then finally, when you get out, you can always see what part of the equation is doing. So that's the final. So it's actually extremely simple if you see how it happens. It behaves on does this decision boundaries, and you can see that finally creates the feature that you are in the setting. Something about big data. So I'm jumping a little. So this big data is something which is big enough to have consistently diverse data that actually explains what is happening. But it's also big enough to actually then average out the errors, because the errors have a different kind of, let's say, stochastic behavior. They are more Gaussian in the system that you can actually, when you train your system, there are enough things going that way and there are enough things going that way and they cancel each other. So they are self-curated data sets. That's why big models, big language models don't make so much of the mistakes that they should do if you are looking how badly the data is generated on them. So, but also, if there is a consistent error, that in some systems, like humans are making consistent errors in programming, so it definitely does exactly the same errors that humans are doing. So you should not use this very much for coding at this stage, when you still have the training data is mistaken this way. It's not any big enough, I would say. And there's also a bad aspect about that, because people are saying that these big models can be used for creativity to understand something about it. They actually totally mediocre. It's an average of things. All the experts are outliers. They don't train the model with an expertise. So this is how transformers are working. So you have a data set like that, and then I can ask you what is that? What is O? I even show you guys. So now there is no O. So there is a certain way that you can actually figure out the last item from the previous ones. They are internal dependencies. So that's the problem that these transformers are solving. So there's a translation, there's a color change that is consistent with the example. And this is also the case where some part of the data can be used to predict some other one. I will look at this similar piece. This is an example. This is a kind of work by Vermeer, a very, very beautiful one. I like this painting. But then you ask doing variation. These are the variations. You can see that really they are mediocre compared to the original. So they are nice. You have some skills, but they are not up to the master. So this is exactly so. Don't try to be. If you are actually doing some writing and using ChatGPT to build your application, what you can be sure about that application is mediocre. It is the average of things. It doesn't actually take out of the system. Really. So if you want to be, and if it actually is better than what you would provide, then you can actually say that perhaps I would go to school again and learn something. Become an employer. So that would be my goal. So how do you find these simple rules? So I just follow Mendeley. So he was looking at the properties of the elements and figured out the periodic table. So they are looking at the solutions, not actually the Schrödinger equation. If they didn't know about Schrödinger equation, that was happening. So exactly the same thing was done for protein folding. They were not actually looking at the Schrödinger equation to do that and solving it. They were solutions. Couple of millions of solutions. Okay, I will finish soon. So, yes, a minute. This is what happens with out of data. My old model, you can see that if you go out of the data, it doesn't work. It gives you rubbish. You have to know the domain which you're using. And this is another out of data model. This is how you can solve adversarial robustness in the setting. If there's adversarial examples, there are these little things like that. So then you can take them out if you have multiple models because they are not in the same place. So if a small circle like that area that always happens with deep learning, then you can take them out. This is about fairness. This is the last thing I say. This is about this EU thing. If you train your model with Finnish data, it does not contain people from other cultures, from other areas like Asia or Africa. And we have a different medical system in our genes. And then you get automatically a system that actually is increasing the data. And this here is an example of the region done on the models. You should not do that. You should have data from all places. Now the question is, how do you use GDPR to do that? That's another question. Okay.
Thank you, all right, and now we will welcome Pekka Kumpula, from the founder and CEO of Seos Design, and he will talk about design and collaboration.
One, two. So, ladies and gentlemen, what a great morning and what a great pleasure to be here. Thank you, Otto, for asking me to join this great event and tell about the things we do in the field of health design. To me, it's very interesting, based on what I saw yesterday and based on what I saw in Leo's presentation, that we can approach this theme of health design from very different angles. And from where I come from, I'm actually trained as industrial designer. I've been working in the field of international product and service development for about 27 years, which makes me a pretty old guy. And today I will be talking about the how design consultancy can collaborate with the players in the field of developing medical devices, and I will be showing you a few of the case examples of what we have done and tell you about the value that we have created for our clients. First of all, this is what we do. So from the 27 years, for the last 15 years, I and we, as a company, Sales Design, we have been focusing on design activities. So we collaborate with various players in the field. We've also been awarded few design awards for the work that we have actually done for our clients. So what is it that we do? We basically work in 3 fields. So industrial design, creating those products and user interfaces to our clients. We help them to create their services, so healthcare-related services, and we help them in creating their brand. These are the kind of 3 dimensions that we work in. Here are some of the clients that we have worked with. Obviously, these are the more established ones. There's about 100 startups that we have collaborated also with, so it's quite a bit of variety in the level of expertise in purchasing design services to the company itself. So what is the value of design activities in these kind of things? Well, there are several types of value that we can bring in. In these case examples, I will take you through some of them that we have found to be doing. So first of all, obviously, it is the end user engagement. Obviously, all of you who have developed medical devices know that the end users are the critical, or rest of the stakeholders for that matter, are critical source of information for developing the products and the medical devices. So you learn from the end users, and we have very good qualitative tools to work with them. We have spent quite a bit of time with different stakeholder groups. For example, in the operational theater. So there's a company, Merivara. We have actually had the great privilege to work with them, and the whole offering, they're providing products to the operational theater. So we have had the great privilege to collaborate with them in all of their products. So here are some operating tables. I don't know if some of you maybe have been in the operational theater, but this would be the table that you lay on when you are operating, and you would have the team around you. Now the team, they have a lot of different requirements towards products. And so you would have, you need to assemble it, you would need to have to work around it, you would need to clean it, and so on and so forth. So one of the things that we figured actually out is the fact that as the team works around the table, they want to put their hips really close to the table itself. And that is because of the fact that if the table doesn't allow you to approach it well, you can bend your back. And if you stay in this position for like 10 hours, you will have some ergonomic problems. So one of the things we figured out, and a great styling feature also, is this cutout in the underneath of the table. This helps the end users to be very close to the table and work in a very ergonomic manner. Also, yesterday there was somebody who was talking about what is really the end value of creating value to the system. And one of the values is lowering the infection risk in the operational theater. Here, industrial design plays a crucial role as you're going to design the products that allow the cleanability of the products themselves. So here you see the operational table. You would have the bellows in the middle, so it's kind of this dented black part. That will bend depending on the position of the table itself. Here, the idea was the cleanability of that piece. So there are a lot of products in the market that are very complicated from that area. And so what we actually did, we created a very simple geometry. Actually, those dents Inside of those dents you have a radius of a 9mm, which is approximately the size of the finger. So you could spray the cleaning material and wipe it with your fingers. So cleanability, which then reflects to the lowering of the infection risk in the theater. Functionality of the products is key. This is something where design activities can provide you really good value. There's a product, Merivara's Q-Flow, operational light in the theater. Actually got a few awards for it. One of the key elements here that we got from following the end users was the fact that the surgeon can actually only touch that handle of that light. So when they need to move it, they can move it from the handle, but every time you need to adjust the intensity of the light or the area of the light, they would need to ask the nurse to adjust the light from the graphical user interface. This would fragment the surgeon's work because they would need to communicate. And so we identified this and actually created a capacitive handle so the surgeon can touch the handle, and not only can he move the light, but actually by tilting the light, twisting it to the light right or left, they can actually adjust the intensity of the light, of the area of the light. This way their work is not that much fragmented, but they can concentrate on what they're doing. Here's another example. This is actually from the Eastern University. There is Leo. There was somewhere here. So this is a startup that we actually collaborated with. And I'm going to use my cheat sheet here to tell you the right words. So these guys are developing, they are revolutionizing the orthopedic surgery through evidence-based diagnostics. So they will equip the surgeon with next generation quantitative tools to enhance clinical outcomes in orthopedic surgery. So what they actually have is, they have a smart optical sensor that enables deep tissue and bone assessment in real time beyond surgeon's visual reach. So by working with the end user, this need was identified, and then industrial and user interface design was used strategically to take that need and then apply that to the product development. So what we actually did, we created this so-called lightsaber. You would have that handle that actually emits light. You can see the light blinking there. And there's a user interface that actually very clearly tells the surgeon when they're doing the analysis through the colors and the usability of the user interface in a very clear manner. So again, design used to create the functionality of the product itself. Ergonomics, obviously a clear value that design can bring. Ergonomics is something that helps the end users to use the products in a correct manner. So first of all, you would talk about the way we handle the products, how we hold them. So the products are understandable, they're easy to approach, they're easy to understand. And here a clear usability issue. If you would look at these operational lights in the field, they have various different form factors. So the key for us was really to take the handle, take the way the end users want to hold the product itself, how to adjust it, and then create the form around that in order to make it very easy to use. Obviously, another great example would be the user interfaces. This is actually the user interface we have created for a surgical table. So clear, understandable usability, clear icons, and not only when there's light, but also in the situations where the operational theater will be darkened. And so we are explaining and telling the story of the functionality through these interfaces in a very clear and coherent manner. Okay, so last but not least, what kind of value does the design create? So as with a lot of things in life, it depends on how much you invest in it. That depends on how much value you create and you get from the design. So no design usage, design as a form giver, design as a process, or design as a strategic tool. So think of the products and services that you have, reflect on what level you are right now, and understand that there might be a next level that the value creation of design can come from. So I will stop here. This is my email address. Please drop me an email if you have any questions or comments, and let's connect. Thank you very much.
Yeah, and now it's time for Lisa Zippler from Certify, and Lisa is he will tell us about an invention he has made, and but most about the product development process. So Lisa, welcome on stage.
Okay, it seems to work. Maybe even a bit too well. Okay, so first of all, thanks for the previous presenters. Great to be here, telling you some examples about design work at Certify. So we're an Aalto-based, or let's say Aalto spin-off company. And I will, let's say, try to incorporate both the human and AI elements of design, especially in health, and through some examples show you a little bit what our path, our design path towards safer surgery has been at Certify. So first of all, I could say that Certify is very we're definitely a need-based company, so we have our roots in a collaboration project between Aalto University and also Helsinki University Hospital. And I started my career as a researcher at the neurosurgery clinic at HUS. My co-founder was working as a researcher at Aalto in mechanical engineering and mechatronics. And actually both of us have visited the operating rooms many times throughout our work and identified multiple of, let's say, a multitude of issues related to bone cutting, and especially soft tissue injuries during bone cutting. So first thing, this. So first thing I have realized in the operating room in multiple different bone surgeries such as neurosurgery and spine surgery, also some orthopedic procedures, is this what you can also see in the images. So injuries to soft tissues caused by surgical power tools and also by manual bone resection tools. And I have witnessed also a couple of cases where these kind of injuries have led to, let's say, near-death experiences for the patients. And I apologize in advance for putting this out here, but I think it's very good to show in a concrete way what we started to solve as a company in terms of clinical issues. And bone surgery overall, I think it was mentioned a couple of times in this, in the previous presentations as well, but it's becoming more and more common. So we have patients who are getting older, and orthopedics is largely related to, let's say, degenerative diseases. And these type of surgeries nowadays, they overall account for actually a majority of the cases at hospitals. And they can also be life-threatening. It's said that these clinical issues of damaging nerves, blood vessels, central nervous system structures, they are actually the most relevant complication in many of these fields of surgery, and especially spine, which is a growing field. So Surgify's, let's say, our design path to solve this issue started from some quite predictable lines of thinking. So we developed prototypes for systems that were able to recognize, for example, when the drill was about to go through the bone during surgery. So when it's going into the wrong place, it would be digitally recognized. We developed prototypes of products in collaboration with Aalto that used like a water jet to repel soft tissues during surgery, to sort of to push them out of the way of surgical instruments. But all of these were very, very, let's say, complicated and costly ways to solve this problem. And even statistically speaking, for medical device startups, the most common, let's say, two most common reasons for failure is, of course, number one, lack of financing, but immediately after that, too difficult adoption process for the hospital. So actually the cost of the product is, let's say you would have a, for example, like a device that works, a new device that works with ultrasound or something like that. You bring it into the operating room, and the cost is only one of the aspects, and on top of that there will come maintenance, storage and logistics costs for the hospitals, and most importantly, training. So training the staff to use new equipment is extremely, extremely costly in a hospital environment. So what we have developed since is called the Halo drill. And the Halo is basically a solution where you only need to switch the tip of your surgical power tool to make it safer. So we figured out that that's the most straightforward way to improve the quality of surgery cost effectively. And the Halo tip is like a tissue selective tip that you can install to, well, theoretically in any type of power tool you have in the operating room. And it is safer for nerves and blood vessels if you get in contact with those. Here you can see an image of the device. So this is the Surgify Halo drill on the left side. And all the technology we basically develop is at the tip. And this is very, very, very easy for the surgeons to use because they don't need to actually learn anything new in order to start to use the product. So from that perspective, I think we have definitely achieved our goal of making it as easy to adopt as possible. So nowadays at hospitals, because this is currently in fairly broad use in Finland and some neighboring countries, the safety is an important aspect for practically all surgeons. But, okay, that's not my computer, let's see. Okay. Yeah, so safety is an important aspect, but in an environment where we have rising costs, speed and cost effectiveness are more and more relevant constantly, actually in all healthcare systems globally nowadays. So the fact that we can protect some of the critical tissues during surgery has actually led to the conclusion that we can also do surgeries much faster. And this is a very, very important aspect we are pushing for the hospitals as well, because when they get used to it, they also realize that actually we can save a lot of time and a lot of costs as well with this type of technology. I'll just very briefly show you, because this is, let's say, related to the design as well, but you can see a little bit how it works. So a conventional surgical drill it's a rotary power tool that can damage tissues. Sometimes you use also manual devices, but our device, the Halo drill, has a tip that's actually made of 2 different materials. So the other one is responsible for cutting, and the other one is responsible for protecting the soft tissue. So it's slightly larger, this kind of ring around the device, and when you push it on the bone, it will compress. And that creates some, let's say, fairly like difficult materials technology challenges. So basically the company is a materials technology company as a result, largely. But now that we have sort of solved the technical issue, we have established a high volume production for the device. This is something that can be done very cheaply. We actually have our production around 400 meters from here in Otakari 5 and in high volumes. I'll probably skip this part here as we're a little bit running out of time, but the device can be used either with Surgify's own drill platform, or it can be used with the existing platforms already in the OR. So basically the customer has a choice depending on whether they have a power system or not. It's very interesting that actually a lot of surgeries in spine and also orthopedics, they're done manually. So the surgeons use like chisel and mallet to operate on, for example, a disc herniation. So if you have a herniated disc, that's what you might be actually going through during the surgery. But with improved safety, we can also improve the, let's say, degree of using these drills in the operating room. So we actually now have around 300 successful surgeries. I just wanted to show a map in the Nordics. This is in using practically all university hospitals at the moment. So if you're undergoing a spine surgery or sorts nowadays, we have ramped up significantly our sales efforts in the past half a year or so. It's pretty likely that you might be actually undergoing it with the Surgify Halo device. So we got you covered in that sense.
Thank you very much, Lisa. That's all that we
have
time for today.
Okay. Yeah, and what I can just tell a little bit more, if there is time, then is this robotic aspect. So robotics is a big trend in surgery nowadays, and tissue selective technologies can also be very important related to AI as well. And there are major, of course, ethical questions as well on how to implement this in the operating room. But this is something that's currently in preclinical use.
Yeah.
Yeah, thank you very much.
Yes, and with that we will proceed to Jari Iskonen from EIT Health and Health Data Sweden, and you will enlighten us on innovating with data in healthcare.
So, hello. So my name is Jari Mieskonen, and I'm working for EIT Digital, based here in Espoo actually. So EIT, if you know about it, it's a European Institute of Innovation and Technologies. And there's a number of these nowadays. And EIT Digital was one of the first ones, together with EIT InnoEnergy and EIT Climate. There's probably 4 or 5 more established in recent years. So we have actually 5 areas where we are active nowadays. One is a digital industry, digital cities, digital well-being, which is the relevant topic for this audience, digital infrastructure and digital finance. And we work in most European countries at the moment. I think we have altogether 20 offices around Europe. I'm responsible of Nordic and Baltic area here, and we have altogether 7 people in these regions. So I'm actually working for the Growth Services. And what is Growth Services? It's actually more or less like a boutique type of investment bank service for scale-ups, or companies like yours who are already successful in your local market. Maybe you have already some revenues and first pilot customers, and then you reach out for global market and you need more equity financing. So we are only working for equity financing, not for public money, not for loans, not for debt, but only for share capital investors. And the sweet spot is between 5 million euros to 30 million euros. We have an excellent network in Europe. We have offices in Madrid, London, Brussels and Berlin, and in Espoo. And our goal is to help your scale-ups to reach for the financing and get the growth speed up. Not only Europe, of course, because a lot of capital markets are US-based and Asia-based nowadays. And we have also good relation to CVCs, so corporate venture investors. There's plenty of those in Europe. And of course, family offices, which are sort of like an extra source of capital with the wealthy families who are interested in supporting one or few industries. Maybe the industries where they made their wealth originally, like maybe health, maybe food and science, maybe only RE or IT. But a lot of these capital sources are looking for fresh deals. And I think Nordic is probably the best place to seek for those. So our team actually covers everything from Nordcap to Cascais, or maybe to Sicily, and we have done deals in all of these countries. I'm also introducing actually 2 programs where we are active today. EIT Digital, of course, is also doing education. We have master school collaboration with Aalto University, with KTH, with the University of Tampere, and we actually do a lot of educational training courses. But we also act as a sort of like a program managers and program sort of integrators. There's artificial intelligence, sorry about the video, I don't need that. Let's move on. So there's a program called FIRE. It's a Finnish artificial intelligence region. It's sponsored by Business Finland, Helsinki City, City of Espoo, Business Finland, and a number of other parties. The beauty of it is that it's an ecosystem of more than 160 companies already. Some of them are service providers, some of them are product developers, and then we have a number of educational institutions like Aalto, like Haga Helia, like other places where you can actually learn more about the technologies or develop actually new features. And CSE Computing Center is one of the partners who are offering actually a pilot capacity in the Lumi computer, which is one of the fastest computers in Europe, which has also linked to EQM's computer, so that if you really have the problems you can't solve with the traditional computers, you can actually ask maybe CSE has a capacity to lend or give for you. These are the partners and associate partners, and as I said, there's a lot of sort of like educational institutions where you can actually also hire a student to make maybe some thesis to your problem, if you can define the problem, like we heard in the beginning. Then I also introduced another program, which is EDI Health Data Sweden. So we are part of this EDI as well. And this is a program where actually in Swedish landscapes they are trying to improve the usage of data, which is not always easy, because in each country you might have a local data sources. You may have university hospitals, they are jealous to each other, they don't share data. And one idea of this Health Data Sweden program is that they would unify the sources of data so that each institution would actually better utilize the national data as it is. And there as well, we are actually offering a number of services. So this is a service catalog for this particular EDI program. And my colleague in Stockholm, Jasman, is actually contact person. So if you have any ideas how you could actually collaborate with the Swedish system, please contact Jasman. You can find all these contacts from our EIT Digital's website as well. So good to be here today, and hopefully we can do something together in the future. Thank you.
Thank you very much, and please take a seat. And we'll then start the panel discussion now. Just to start out with, I would like to ask, I think all of you, most of us know that AI and even quantum computing is beginning to be used in the pharmaceutical industry to accelerate actually their sort of drug development or innovation process, to accelerate the identification of new prospective targets. And if we try to parallel that to the innovation of medical devices or non-pharmaceutical solutions, in what aspects can AI accelerate the innovation process in the medical device domain? So I'll pass it on to you, Leo, first.
I guess there has been quite a lot of big progress with being able to actually predict the form of the molecules in the system. For example, AlphaFold is a great example, and that is already used. There are many, many alterations of that already. There is one fundamental problem that remains in the system, is that when the proteins they are folded in crystal form, then you actually know what form they are. But in biological systems, they are in water. And that combination is not something that we have the data, because we have not been able to crystallize those, then we don't know the form, and then we don't know the solution that we could actually train for. So that part is still, there's a long way to go of traditional research when you start doing that. It's not only the forming, okay, I know the crystallized form. It helps us to understand the result, but it's not the full game. Compared to medical devices, I think that's what is coming in out of is very much about the capability of seeing more. They become in the setting that they can combine data from multiple sources, and they can actually bring that in a intuitive form back to the and that, I think, is something that has done. We have a super microscope in our hands. And I have seen many applications here already that has tendency going on. So there's both sides are actually going to benefit from that.
Thank you. That's a great question. Obviously, AI is coming from various directions, and we as a design consultancy are continuously seeking ways that we can use AI in our and our clients' benefit in the development process. So from our perspective, in regarding developing medical devices, we're using it for creating text. Obviously, it's great use for that. But not only, but also in creating product sketches. So we use HyperSketch as an app to create multiple different industrial design sketches from which we can then choose and apply and use them. And we are currently looking for a mechanical engineering AI software that could help us really to get multiple ideas for mechanical joints. So that's from our perspective.
I think probably like AI use in medical device design is a bit of a challenge because first of all, overall, I think it would require some sort of like general artificial intelligence actually to design a new useful product from scratch. Not in all cases, there might be some specific examples, but usually. And secondly, I think compared to pharma, where we are dealing with receptors and you know, pharmacokinetics and stuff like that, you know, you could actually benefit a lot from AI, but then medical devices often, and the usability of medical devices, they are designed for humans, by humans. However, there is an example which I was gradually entering towards my end of the presentation, which is medical robotics. That is a field that will benefit significantly from the development of AI, and of course there are some significant safety concerns which Surgify is also addressing with its technology, but that creates some big questions. The traditional one being, of course, that if there is a complication, who is responsible? Is it the manufacturer of the robot or the surgeon or somebody else? Probably depends a little bit, but then also secondly, that like how do we approach through design situations where, let's say, if we have a fully autonomous robot doing, let's say, a spine surgery or knee surgery, is it actually, does it make any difference if the robot does it automatically, or if the surgeon is, for example, controlling it by pressing a gas pedal or something like that to make it advance, even though they would not actually be able to impact the end result at all. They might prefer to do that, but there would be many questions about responsibility and so forth we will really need to address when we progress with AI and robotics, especially in the field of surgery.
Since I'm not a scientist, I cannot really sort of check all these areas, but I know from our cases that the visualization and the picture and image processing is very, very advanced nowadays. Partly thanks with RE, of course partly thanks because the cameras are miniaturized, they are better in quality, the pixel size is smaller, and that's not really on pharma, but it's more like health overall. And I think the pharma is another area of health which is completely revolutionized nowadays because of RE. There is much speedy processes to test and verify some of the molecules. So that will be another area which will have major breakthroughs in the near future.
Thank you very much. So I have a follow-up question on this. So and maybe it's more for you to answer, Pekka, because when you want to have use artificial intelligence, and yes, we are very far from having general intelligence, as you say this, but you need to have like good quality data to train or to develop and then train and verify a model. So in terms of ergonomics, are there some standardized principles or rules, as Leo called it, that we can use in order to create a model that for non-designers can be used to optimize the ergonomic design of their solutions? Does such data exist? Can we create such a model, do you think?
So if you look at modern, let's say, affordances, there are the ways that you can actually operate something is that AI can bring you tools that do something that you cannot do by hand. For example, if you do a rotated movement like that, it's always restricted, actually, the way how your wrist behaves. But you can make an AI system where you can control that so that it turns around all the time. So these are the kind of new affordances in your normal tools you get. It actually would improve your system to operate. This is what I meant with these kind of new capabilities that are coming in. And you are right to say that the robots are the one area where the changes will be kind of the most major, because you have this kind of new ways of doing things that are not possible with the tools. That's the small example.
I'll use mine. That's a good question. Obviously, there are a variety of different types of products. They vary in size, in the way we interact with them. They have different types of user interfaces and points of interest. And so I'm pretty sure that in the future, we as a design agency will have an AI app that allows us very quickly to kind of categorize the type of product we are developing and ask for kind of ergonomic parameters that we could use. We are already seeing that in styling purposes, so we can draw a really quick sketch, just 2 lines, and we can get 200 operating tables provided by an AI software. And so they might not be perfect, but you could get the detail from here, a detail from here, and just kind of combine them, and it will speed up the system. So in a similar manner, we have AI applications that provide us kind of mechanical engineering solutions, and why not ergonomics? So it's not if it will be here, but it will be, and it's just a matter of time.
Thank you very much. Lisa, I'm a bit curious about the solution that you have developed, because you say it's tissue selective. And so how is your solution? Have you used data? Is there artificial intelligence incorporated into in order for it to detect the tissue differences?
So, yeah, thanks for the question. I think like the product concept itself is developed by human brains for sure. The details of the design, the materials, testing and stuff. Actually, the product is largely tested with robotic assistance as well. So we have a robot in there which is doing like huge amount of surgery with the device and seeing how it survives and tolerates. But I think maybe the biggest area where Surgify has currently used AI is on the robotics side. So as mentioned, it is still in the preclinical stage, so implementing this tissue selectivity or tissue selective product in robotic surgery. But there are some major questions like, because theoretically the whole surgery has to be planned on computer in advance. And obviously there's a major role for AI as well. Actually, the human cannot program the whole surgery from the all movements of the robotic arm, so there has to be AI assistance there. And secondly, in detecting, for example, tissues, because the product can be used also to detect the type of tissue digitally that you are drilling. That can be very useful in automation as well. So, combined, I would say we have a pretty significant use of AI and machine learning solutions there, but of course the concept and the need has to come from humans.
Maybe if you allow, I will add one more thing for AI use cases. When I was a young engineer, by the way, I was researching robotics and economics of robotics. So at that time there was no medical use cases 30 years ago, but now there's plenty of those. Interesting to see. And I think what is interesting for all of you guys who are from the research-based spin-outs is that you should do your homework as well when you go to meet investors. Because investors are using AI as well to check your competitors. And in my early life, I met an Aalto University professor who has invented a flow, sort of like a light concrete. And when we started to investigate it, we found that there was a DIN standard in Germany already for that same product. But the professor said that there's no competition. So I'm just saying that if you invent anything nowadays, the investors will use ChatGPT or whatever system they want, and they will figure out just using Google or whatever search engine, and they will find similar products, not maybe same, but similar. And then they will compare you against them, and then they will decide which one they invest in.
That's very interesting. And you can actually keep the microphone, because I would like to ask, what role do you see that ChatGPT, just saying it as a simple concept, how that can be used by the innovators to search for the right investors for their case? Do you talk about that in your investor network?
Well, of course, it works both ways. So you can use, of course, the same search engines to find suitable investors. And then, but you can also order pitch book to check who are the investors in Europe or elsewhere. And you can check what is the focus of those funds, or do they have any funds? Because the worst thing you can do is to speak to somebody who don't have any money. So then you will waste time and they will waste time. But of course, I think Google knows a lot, ChatGPT knows a lot, and ChatGPT is actually an excellent tool for comparing things. You can compare banks, you can compare VC funds, you can compare technologies, and it's not perfect, but it gives you sort of like guidance that which things you need to take into account.
Thank you. And staying with ChatGPT, I have a question for you, Leo, because in your talk you said that the creativity is sort of deleted out of the data, right? Because it's not on average. So, and we had last year we had one innovation fellow who tried to use ChatGPT in their brainstorming session, and I wasn't impressed by the ideas that it could come up with. But it's also a matter of, if you are an expert in something and you propose an expert-based question, then you get a more high-quality answer from the ChatGPT, and if you ask non-intelligent questions, you get a non-intelligent answer from the GPT. But in terms of this, that the creativity is sort of deleted out of the data, what role do you see that large language models can play in terms of supporting the creative process in innovation?
So you kind of get the state of the art out of it, because it is using what is already existing, so what comes out of it. And you are certain about that is ChatGPT has a multiple personality disorder. So if you are paranoid and you write something, it continues with the paranoid text. I remember the first type of example is that I was making a computer crazy. So what I was saying, okay, look at the mirrors, why did it happen? It is because your prompt was crazy. So that's essentially that. If you say something stupid, it will continue like that. Because otherwise it's not a stochastic pattern that it really is. It tries to predict what is the next word. So you start with something stupid, it continues. And if you have some expertise and you are actually creative in a way, it tries to find some of the experts that are still on the training data on that aspect, because it is a multimodal behavior it has. So it's not totally making the average of everything, it is making an average of classes of different modes. So there is some ways that it is still not creating something that doesn't exist in the data set. If you are the only intelligent person in the world, it would not actually be able to continue that in an intelligent way. So that's part of the fun in the setting. So it's not the real person, and very often Pearson thinks that it would have a responsibility like that. And when it's trying to train out with human data to make it the real person, and that I think is a step backward, because what it does, it takes out the diversity of the human information. I would like to have ChatGPT that is trained with the data from the 50s to be able to ask what they think about things. And not to make it say that if they are not according to our current values, they would not exist there. We take those parts away that we think about what is valuable for us and prevent it using it in that kind of way. It's just a record of what people have been doing.
Just a brief addition. I think we're living very interesting times also with this like reasoning AI that can sort of do stepwise reasoning and logics. I mean, obviously that's very in the beginning, but quite quickly developing. So I guess we will see more of that probably in the very near future, and I think that could also answer to some of these questions that we have been discussing and help with some of the design work in a different way.
Just having a comment on that, if you have a story about Alice and Bob and making a cybersecurity application, and then you ask it in terms of Alice and Bob, and it actually answers a very nice kind of standard answer for that is perfect that you can use. If you change the names of Alice and Bob, it cannot answer. So there's a degree of level how much it has trained for a certain data, because Alice and Bob is always used there. It has not understood what it is talking about. So one has to be careful about the reasoning part.
Yeah, and I have a final question for you before we will begin a Q&A with the audience here, because I'm sure you also have some very good questions. So it's actually about a question regarding a bit about the ethics of using AI and maybe particularly ChatGPT, because it's so accessible for everyone of us. It costs a lot of CO2 emissions every time we use the ChatGPT. So to me, at least, that's of a big ethical concern, that we actually burn off quite a lot of the earth every time we make a search. So what are your considerations? How can we go about a sensible use and professional way of using these tools in our processes?
Well, I suppose the quick answer is that you only use it when you need it. But I suppose people are using all kind of sort of IT-related devices for entertainment, for all kind of things. So if you use it when you need it, I think it's ethically quite okay. And I think it's also the thing what he mentioned about these risks of who is guilty of mistakes. It's something quite human to think about it, but I mean, there's mistakes all the time done by humans. But it's quite natural that everybody is looking for somebody is guilty for something. But there's risks of doing things. But there's also risk if you don't do anything.
Yeah, I think the climate impact is a good point and definitely should be considered. I suppose development in AI algorithms. I mean, now it has of course increased the sort of like a burden of that, but hopefully, and there are probably experts who can comment on that, but much better, but for at least the same performance, and hopefully decrease actually the required resources. But probably a complex question, and of course we hope one day it brings us nuclear fusion or something like that. So that's the idealistic way to think. But for me, actually, medical devices, I think there's of course the data aspect. So data collection is hard for AI training in this field, and it is a big question in terms of ethics. And secondly, indeed, like the requirements for the performance of AI based on actually any automation in medicine is significantly higher than if a human would do that. So if you think of surgical complications or misdiagnosis or something like that, in order for the AI to get approved to be used in that indication, you have to show significantly lower levels of complications or such. So that has of course been the case so far in many other things like our self-driving cars and so forth. But these are like fields that are surprisingly similar in a way that we are dealing with human life.
So yes, we use a lot of energy when using AI, but compared to the situation that we would not use AI, we would use significantly more time in developing the products and services, and also this has an impact. So which has a bigger impact? I don't know. So I think it's all kind of relevant depending on on the use case and depending on what you compare it to?
I guess when you're using AI for system, it spends energy, but I think that the solution provides actually saving energy. So this is the type of one should actually look at the full balance, one side and the other side in the setting to get it right. So yes, of course, we try to do it. I'm working for embedded systems, and then one of the ideas is to make one of these language models as small as possible and good enough. So I guess in the future you will see mobile phones, for example, that have a certain language model on them, and they are lots of developing them. I think Apple will be perhaps the first one to bring it in the devices. So, and that doesn't really kind of consume energy so much in the setting because it has those utilities and it is kind of working locally. So that is the problem when you start it. It will become expensive when you train it out and you figure out what are the essential parts and how you train the system in an efficient way and what are the algorithms that you're actually using. So how you actually so-called quantize the model and prune it. So it will actually bring those capabilities in your hand. So then you are not perhaps so worried about anymore about having Lumi spending too much energy.
All right, thank you. And with that, I'll pass the word to Patrick to take some questions from the audience.
Absolutely, thank you. We can take another 5 minutes from the long coffee break. So, Susanna, we have a distinguished panel here, and I'm the mic runner. So, please, any questions? Who's going to be first? Yes, sir.
Thank you for the talks. My question is about AI can be really useful in healthcare domain and everything, but it is about, as Leo said, kind of averaging the results. But also we know that it can be used for personal level analysis, personalized treatments. I actually want to hear about your vision about this part. How can we use AI for more personal perspective, personal treatments?
I guess we have those systems already. In a way, for example, if you have let's say this artificial pancreas in your system, that you have a measure system that is taking your blood sugar measurements, and then you have an insulin pump that is reacting with that personally, always according to your own level of sugar, so that is an embedded control system that is using AI for it. So, and it is much secure when you go to sleep, for example, then perhaps even if you have eaten a lot in the evening, so there's a proper insulin coming in at that time. So it's a wonderful system. It's always already on the works. So really, yes, we will get these automatically reacting systems that can keep you healthy in that sense.
Well, I think in medical procedures, one of the benefits is that AI could help you to choose the correct procedure. I mean, currently it is even actually used to make decisions whether or not to treat certain type of cases, and that is at least pretty far in such regard. But secondly, also what kind of procedures, and then how the procedure could be adjusted based on the patient. So there are various risks depending on your individual anatomy and health situation and so forth, which could be basically considered in this kind of AI model. And then in theory you could make the perfect decision based on the data you have on whether or not to treat, what kind of approach to choose, and thirdly, what kind of instruments or implants you would install to the patient and so forth. I guess it's pretty similar to, let's say, individualized pharma in that regard, but I believe it's going to be big there.
And of course, what I would say, this is what I said is about this, let's say, diabetes treatment. It is actually a decision whether you treat or not. It's the amount of insulin that you put in is actually a decision about treatment. You figure out that when you're doing something that people say that should not be done, and when somebody in the other corner you're actually doing that already. So one has to figure out what means it.
Excellent.
Make a problem or something that is not a problem.
Very good. One more question. Anyone? Come on. Yes, sir.
Thank you for the great panel and great presentation. So my name is Mika Star. I'm from the Kumukor, from the telecom side. But if you think about yourself in 10 years, so what kind of problems, what kind of questions you would, in this kind of a panel, what kind of problems you would kind of describe, discuss in the near future, 10, 20 years? What kind of challenges in the future?
Well, at least I would imagine that we would have much more specialized sort of pharma products for individual use cases based on our genes and our response to different chemical substrates. At the moment we all use the same Burana or aspirin for the same headache, but maybe in the future we have different headaches and we have different cures for those based on our personal sort of response to these medical treatments. Maybe in 10 years already, but hopefully in 20 years.
I think that we are going to see more and more also implantable devices. There are interesting developments also in, for example, sort of brain-computer interfaces and so forth. I think that's going to be a big thing, and of course, depending on the rate of development of the artificial intelligence, we might also need to mitigate the risks associated with it, not only generally speaking, but also in medical procedures, data security and so forth. I think we will be working a lot on those. But less human involvement, less errors, more personalized, less invasive as well, in many ways.
So that's a good question. I personally believe that in the future, if we look at the mega trends, people are living longer, we're getting older, we're getting more obese, we are bigger, we are fatter. We are going to need to tackle those issues, and we as a design consultancy, we start to see that already in the design briefs we get. So the type of products and services we're creating are to support those diseases that we are getting through getting older and getting bigger. So we are already tackling that, and that's going to get even worse in the future.
So I guess I follow you in some of those cases. I think that there's already going to be much more information for people about what condition they would be, and there's this kind of a personal assistant that actually keep you on the road. That's we're actually going to be more healthy in the future. So what I think also the type of let's say non-invasive, let's say surgery would be also kind of a nice thing. Why wouldn't you need a kind of instead of having big devices and you're breaking things up in the way, why don't you just do everything with a needle type of a structure? Know where they are going and use that, or then having some kind of also kind of let's say, using blood veins for actually to access to different places, like they are doing it already on the sense, and they are becoming more intelligent in how they act on the things. So we are going to have an access to interiors in a totally different way than we have now in the setting. So this would be the kind of first items that coming in. So what would be the type of tools that you are using? I suppose that much of them will be so that they are easy to use. It's like, let's say, ABS kind of let's say systems in your car. When you push the brake, then it actually brakes in a sensitive manner. So if you have a surgery knife in a certain thing, it behaves in a sensible way. It looks at your intention, and it does what your intention is in a proper way, and you don't know, you don't have to have this control micromovement that you can actually create with an AI system. I can tell you more small ideas.
So to answer your question from a total non-technological, non-product focused answer, I think that because we see so much automation, or we expect a lot of automation and high advanced technology getting into the clinical domain, and at the same time where we also you know, we have to look at how many people do we actually have to carry. Do we have available to take care of people? I see that in 10 years' time we will have some struggles. I think the problems that we will be focusing on there is actually how to organize our healthcare organizations around the care processes and the incorporation of all these technologies. And in that respect, I think we will also maybe get to see that we will need a new type of employees in our health systems. Employees that can actually act as bridge builders between the health professions and the technologies. And right now we are not really educating such people. So I think that's going to be one of the problems that we'll have quite soon. And with that...
Can I just ask one more question of the panel? Have you started using interactive voice, AI voice, in your design processes yet?
I can actually say one statement about that in that is related. So that's about digital divide. So now we have been kind of facing the problem that these AI systems become more and more complicated to use in many occasions. So computers become more complicated, and we say that the older people don't follow them in an easy way. So what I would say that what is going to happen is that we are going to abolish the digital divide in such a system that they are easy to use, but they do fanciful things. So this is about whether it is about voice or whether it is something else in the system or whether you just have that kind of a... We are actually going to close the digital divide, and one of the good parts about this is that our productivity is going to increase with this one because we don't have to learn the stupid say formats that we have to put the data in order to program some R or something like that. The other part, which is a little... This is about democratizing, but first you have an access that is even. But sometimes when you have an access, it's not a good thing because it also gives the capability of doing some bad things very easily. Now there's the question of ethics, how you actually prevent a good robot that actually kind of demands your capabilities of, let's say, has capabilities that you can control them, how to clean their house and do some dishes or something like that. But also you have the robot to do some accidental things that could actually kill people. Now the question is at what level of difference will be that when you have those capabilities. So we will see a wonderful future with this one. That is interesting.
Last comment here. So ergonomics, usability, that's the key in making things pleasurable and easy to use. I personally hate to interact with these kind of typing type of user interfaces. I struggle with them. I'll be much more humane to use an AI support with just having a nice chat and discussing with it. So looking really forward in having that type of solutions.
Well, thank you very much, everyone, for your contributions here. And Patrick, the word is for you to continue.
Thank you very much. Time for a coffee break, everyone. Thank you very much to the distinguished panel. What I would say is that these seats at the front, they are very, very comfortable. They're like executive Danish design, all this kind of stuff. So please feel free to also move forward a little bit. They're cheaper.
Testing, testing. Testing, testing, testing.
get started and the others can join us when they finish their triple espressos. So, there's still some chairs here at the front. So welcome to move forward if you want. We have a fantastic panel discussion and set of conversations lined up for you now. So it's going to be led by Katarina Rovinen from HUS, Development Manager from Helsinki University Hospital, and it's all around innovation through co-creation of partnerships, an area very close to my heart. So please give it up for Katarina. She's going to welcome on stage her colleagues from the panel as well.
Good morning, everyone, and thank you for the kind introduction, Patrick. I'm happy to host this session about innovation through co-creation and partnerships this morning. My name is Katarina Rovinen. I work as a development manager in HUS Helsinki University Hospital. I work with company collaboration and innovations, and I'm happy to start this session. We will have 5 presentations from Finland and from abroad, and then we will have a panel discussion afterwards. I will start shortly about HUS Helsinki University Hospital, what it's about, and then our One Innovation Ecosystem initiative we have called Clever Health Network. Maybe some of you are well aware what is HUS Helsinki University Hospital, but here in brief, we are the largest hospital organization in Finland and one of the largest hospital organizations in Europe. We are offering specialized medical care for our inhabitants. In our area, in Helsinki and Uusimaa area, there lives about 1.7 million inhabitants. But we have a larger catchment area for tertiary care, and there is 2.2 million inhabitants. But there's some specialized care that is taking care in our hospitals nationwide. So in whole Finland, there's about 5.7 million people, and we cover, for example, organ transplants and some kind of treatments for children's diseases. We have 21 hospitals and about 28,000 employees in our hospitals. We are the second largest employer in Finland after the city of Helsinki. And annually, about 700,000 patients are treated in our hospitals. We are leading development of digital services in healthcare in Finland, and last year Finland was ranked first in DigiBarometer indicator that evaluates countries according to how they enable, utilize and benefit from digitalization. And what are the drivers for healthcare digitalization? These are very familiar for all of you. Aging population. So the increasing of chronic diseases, it's worldwide challenge. So we need to develop more efficient services. Finland is a long country, and there's a shortage of manpower. But fortunately, our patients, they are willing to use digital services. And the technology is rapidly developing, and we have a lot of amount of data that we can use to develop new solutions, new services. and with the help of AI, we can develop these services. One of our innovation activity in Helsinki University Hospital is Clever Health Network. That is an open ecosystem for public and private collaboration. We are combining in this ecosystem our clinicians from our university hospital and the expertise of private companies. And together with our clinicians and companies, we are co-creating new solutions for global markets. And in these projects, we are utilizing the health data that we have in Helsinki University Hospital. We, in HUS, we are responsible for the scientific research and the validation of the solutions in these projects, and the companies are responsible for commercialization of these solutions. We've been running and coordinating this ecosystem for 7 years now, and it is funded by Business Finland and the partners we have in our ecosystem. Here you can see our partners at the moment. We have 20 partners. We have both SMEs, growing companies, scaling up companies from Finland, and international companies. We have medtech companies and also companies from pharmaceutical industry. We are coordinating this ecosystem together with Spinverse consulting company, and as mentioned, Business Finland is funding this ecosystem. But we have a lot wider ecosystem. In our projects, we can have other companies also, which are not in our core ecosystem. We're trying to find the perfect partners for each project that we have. So we've had a lot of other companies, research institutions, and other stakeholders also. We are collaborating actively with EU projects that we are coordinating in Helsinki University Hospital. Health Capital Helsinki is very important, our stakeholder in our network. Also Terkko Health Hub and Biodesign Finland. Healthproof Helsinki is one initiative where we work together with City of Helsinki and Metropolia University of Applied Sciences, where we offer expert services for companies and testing facilities. And we also have other stakeholders. And about our projects in Clever Health Network, so these are joint development projects, and there are 3 main elements in our projects. Yesterday we heard about need-led or idea-led needs, and in these projects we need to have a clinical need. So we need to have some clinician who has some kind of idea or challenge or idea that he or she wants to develop together with companies. In our projects, we are utilizing our health data that we have a lot, and then this joint development co-creation with companies. So we are doing something new together, something that has not been in market yet. So we are doing something new together. And the solutions will be taken into use in our hospital, and the commercialization, as I mentioned, and the actual business is taken care by the companies. And we are making contracts for each project individually. And as I mentioned, the data is very crucial in our projects. Here you can see some numbers about the data we have in HUS Data Lake that can be used via HUS Acamedic, which is a secure, scalable and virtual research environment. Here is some project examples that have been in our ecosystem. So the development of home dialysis is the first project that we have come up with the Fujitsu, and they will commercialize the solution. So they have been developing a solution for patients suffering dialysis, and they come up with the app that the patients can treat themselves at home and have a connect with the clinicians in the hospital. Head area imaging analytics is going on. They are developing different kind of algorithms to detect different kind of brain bleeds. Gestational diabetes, you will hear more later today. My colleague Mikko will present that project afternoon. And then there's AI tool for diagnosing for rare diseases, and also AI tool for treatment of acute leukemia. And there's some other EU projects that we are involved also. This was shortly about how we collaborate in Helsinki University Hospital, what kind of innovation activities we have. We have, of course, a lot of other activities and initiatives, but this is one of our ecosystems that we collaborate with the companies. And now I'm happy to give a floor to Pinja Kruk, and she will present her vision and her presentation from Novartis.
Good, thank you. I remember I was in this event, I think it was 2019. Was that the last time this was organized? I was then at the audience, but happy to be on stage today. And I know the name of the event is Health Design, but I actually want to start with the other side of the story. Because how many of you knew that cardiovascular disease is actually the reason behind 30% of all deaths globally and in Finland? How many knew? Hands up. Quite many, because I think the one that comes second, cancer, is actually the one that people usually assume, but the cardiovascular disease is the biggest reason. And at the moment, how does this work? Oh, no. There are over 300,000 people living with ASCVD in Finland. That's more than population of Espoo. And because the volume is so big, also the costs for society are big too. So annually, on average, the cost that these cardiovascular disease cost per citizen is actually 640 euros annually. So each of us, even though we wouldn't have the cardiovascular disease, that's the volume. The sad news is that many of these patients actually find out that they have ASCVD only after they have had myocardial infarction. And annually in Finland, 11,000 people survive the infarction, which is basically the same thing as a heart attack. The good news is that it is actually impossible to prevent further events, because these patients who have had their first heart attack have a very high risk of getting a new one. But if we're able to control some risk factors, for example, LDL cholesterol, we can lower this risk and with that the costs. The sad news is that this risk factor controlling management is called secondary prevention, is not happening optimally in Finland at the moment. So we know that at the moment, 1 in 5 patients actually has another heart attack within a year. And even more patients when we look at the 5-year time frame. The good news is that a couple of years ago, we got a national cardiovascular disease register in Finland, a quality register, where we can see how this secondary prevention is happening in Finland at the moment. From the data, we see that actually 40% of these patients have not had their LDL cholesterol measured within 18 to 30 months after the heart procedure. So we're not doing well on secondary prevention. And as said, the cost of this is big. So I want to share with you today how we at Novartis Finland have approached this problem together with our partners. But before I do that, I want to quickly introduce myself. I'm Pinja Krug, and even though I dropped some medical knowledge here, I'm not a medical expert at all. My background is in service design. And in Novartis Finland, I work as a healthcare partnership director, and I lead a team of service designers and strategic designers. And so we have a quite unique team. We partner together with Wellbeing Services counties and other partners. And one of the most common questions I get is, why does a pharmaceutical company like Novartis have service designers? Because we're a huge global company. We have over 70,000 employees globally, 100 being in Finland. And here you can see our core therapeutic areas. We have a very solid scientific background. We invest a lot to science. So why do we have service designers? So we actually want to our motto is that we're part of healthcare. Because if the patient isn't at the right place at the right time, how can they get the optimal treatment? And this is the reason behind why we have invested in service design and why do we do partnerships. And I think cardiovascular disease is actually a great example of where we have a clear common goal between all the stakeholders. Because obviously it's terrible for the patients and their close ones if they have to face this reality of getting a heart attack or then have recurring events. It's also very heavy on the resources in healthcare for the healthcare professionals if the patient keeps coming back because of the same reason all the time. And as we know, the costs for the society and for the Wellbeing Services counties are huge. But it's also the common goal is clear for us in Novartis, because if the patients disappear after having the infarction, how can they be treated? So that's the goal of the partnerships in Finland for us. But coming back to how we approach this problem, is that a couple of years ago, we created this ASCVD program called Sydänohjelma Polku. And our aim is to improve the secondary prevention in Finland. And there are a couple of steps we do in Polku, and we have now partnered with 4 different Wellbeing Services counties in Finland. And we always start by understanding the disease burden in the area, and we can then model the impact potential of prevention. But I'm not an expert on this, so I have a short video of our medical lead and our external partners. So let's hope this works. It's a 2-minute video.
No, Varttiksen, Siun Soten ja Esiorin yhteistyössä tekemä tutkimus tarkasteli sepelvaltimotautitapahtuman saaneiden potilaiden uusintatautitapahtumariskiä ja hoitoon liittyviä sosiaali- ja terveydenhuollon kustannuksia 5 vuoden seurannassa. Tämä uusi tutkimus antaa tietoa sepelvaltimotautitapahtuman jälkeisen sekundaariprevention nykytilasta ja hoitoon liittyvistä kustannuksista Siun Soten alueella.
Tässä tutkimuksessa pystyttiin osoittamaan se, miten sydänpotilaiden kokonaisriski on yhteydessä pitkän aikavälin sote-kustannuksiin. Tutkimuksessa potilaat jaettiin 5 eri riskiluokkaan pohjautuen heidän sydäntautitapahtuman uusintariskiinsä. Tutkimustulos on myös se, että me käytimme tässä tutkimuksessa Smart Reach-riskilaskuria luokittelemaan näitä potilaita heidän tämän uusintariskinsä perusteella. Ja tämän käyttö vaikuttaa hyvin lupaavalta. Ehkä yhtenä keskeisenä havaintona myös se, että kun tarkasteltiin näissä riskiluokissa potilaiden LDL-arvoja, niin edes korkeimmissa riskiluokissa ei saavutettu riittäviä hoitotavoitetasoja.
Tutkimuksen tulosten perusteella voi olla mahdollista luoda työkalu, joka helpottaa suuren riskin potilaiden tunnistamista ja samalla luo motivaatiota potilaan riskitekijöiden hoitoon sekä potilaan että henkilökunnan kannalta. Aiomme hyödyntää näitä tuloksia esimerkiksi digitaalisissa hoitopoluissa. Aloitimme vuosi sitten sepelvaltimotaudin digitaalisen hoitopolun vakaoireista tautia sairastaville potilaille ja nyt helmikuun alusta olemme aloittaneet myös sydäninfarktiin sairastaneille potilaille vastaavan digitaalisen hoitopolun. Sepelvaltimotautikohtauksen jälkeen riskiluokittelu voi auttaa potilasta ja hoitavaa lääkäriä yksilöllisen hoitosuunnitelman laatimisessa. Tämä uusi tutkimus osoittaa, että keinoja löytyy hoidon vaikuttavuuden lisäämiseen, koska uusien sydäntapahtumien estäminen säästäisi hyvin merkittäviä summia kokonaiskustannuksissa.
Riskiluokittelulla päästään tällaista perinteisestä one fits for all -ajattelusta, jossa lähtökohtaisesti kaikkia potilaita hoidetaan samalla tavalla, kohti stratified medicine -ajattelua, jossa potilaan kokonaisriski on se keskeinen tekijä sen hoidon toteutuksessa. Tätä kautta me päästään rajallisten resurssien tehokkaampaan käyttöön.
Laadukasta terveystietoa tarvitaan terveydenhuollossa päätöksenteon tueksi. Tämä tehty tutkimus on vain yksi esimerkki siitä, minkälaista yhteistyötä me voidaan tehdä eri hyvinvointialueilla, jotta potilaiden hoitoa voidaan kehittää entistä vaikuttavammaksi.
Yes, so we did this study in Siun Sote, but now we have a modeling tool which we can utilize in all other well-being regions in Finland to really understand, as said, the current situation, but also to simulate how, for example, treating certain risk factors, what's the outcome for the risk for the patient to have another heart attack, but also what's the impact on social and healthcare costs in a 5-year time frame. So we start with the data to really define what the problem looks when looking at the data. But then we move to what, as a service designer, is kind of the core for me. So we are in the healthcare service county. We interview patients, we interview specialists, physicians, nurses, both in specialized healthcare and primary healthcare. We really try to understand what are the current ways of working. Where are these patients? Because they don't disappear. They might be in other clinics. What are the ways of working there? And then we identify the key stakeholders that we collect together to really co-create the solutions. And here we do it always tailor-made based on the area. So we don't have any ready-made solutions we bring. We look at the regional needs and then also their existing systems. What would work for them and be easiest for them to use. So as said, our aim is to improve secondary prevention in the area. And we're doing this work in multiple areas, but we also have some great results already that I want to share with you. Heart Hospital launched their digital follow-up for ASCVD patients in September. And we partnered with Sydänsairaala to really understand the needs from patient perspective and healthcare professional perspective on what would be the optimal digital follow-up for these patients. And this Oma Sydän app, My Heart app, is also integrated based on those findings to their ERP system, so that the nurses and physicians don't have to do a lot of manual work. Everything is as easy for them as possible. So this was launched in September, and now patients get, after they have gotten home from after their heart attack, they get automatic reminders of their check-ins and follow-up visits. They get support and guidance so they can treat themselves optimally at home. And they can also contact Sydänsairaala Heart Hospital through this app. And the results are really great, because we can already see that over 75% of patients hit their LDL cholesterol target during the 12-month follow-up. And we can also see from the National Coronary Disease Register that on average in Finland, it's usually just over 20%. So the difference is big. Secondary prevention is actually happening in heart hospital areas. And maybe some of you remember this, because this won the Effectiveness Award last year in Vaikuttavuusseura event. But I want to end with not just the data piece, but a quote from a patient that took part of interviews and co-creation sessions in this. Sorry, it was trying to put some automatic update, Otto, just for you to know. But yeah, this is a quote from a patient that we interviewed during the creation of the app. And I think this quote shows well that even though data is very useful, we needed to set goals to really understand the current state and to track our progress. And officially, secondary prevention is about controlling those risks. But I think that the more interesting part is actually the people perspective. Because what we found out through these interviews is that when these patients got home after the heart attack, most of them were really scared. They knew, in theory, that they should be active, they should take care of themselves, but most of them said that they're even afraid to go for a walk or a jog, because what if they get a new heart attack when they're out there alone? So they ended up, they wanted to live their life, but they really didn't know how. And that's why, for example, the support that was created to the app is really trying to motivate these people to stay active. And I think that's what a good secondary prevention looks like. It's not just about the numbers, it's also how can we design seamless services that really support people in what they want to do, live a full, happy life. That's important, not just the numbers. Thank you.
Thank you, Pinja Krug from Novartis. And if you have some questions, please keep them in your minds. After the presentation, we will have panel discussion, and then you will have a chance to ask your questions. But then I will give a floor to Timo Alaläkkölä, who is the head of testing and innovations in Oulu University Hospital.
Thank you. Just an audio check. Can you hear me okay? Yes, thank you. So, today I will be sharing some northern perspective to this topic. We in Oulu, we condense these operations with public-private innovation and healthcare innovation in the Oulu Health Labs, and that's in the core of the presentation, but I will also share some insights into our current Future Hospital 2030 project. But let's get started. So my name is Timo. I'm from Oulu University Hospital, and in the longer term, that is Wellbeing Services County of North Ostrobothnia. Very easy to know that. I have a career in innovation procurement. I used to work for Nokia for 10 years, but already more than 10 years I've been in the life science sector and been enjoying a lot. It's been a blast. I love bringing new health tech available to be utilized by the healthcare professionals and provide the best possible care for the patients. Outside office hours, I'm in this Lykra. Many times I like to do endurance sports. I will come back to that how it's connected to healthcare also. And then I'm also doing my PhD. I'm a PhD researcher at the Oulu University Business School. And that's something that I love to do. It's in research about health innovation networks. So that is also connected to these daily activities at the office. But then, let's set the stage. In the earlier panel today, there were mentioned that this AI is of course coming, and the quantum computing is coming, and yes, it will be the biggest change ever in the technology in our history. So this quantum computing processing power, it's something that it can solve challenges and problems that we did not even know that existed. And the AI solutions previously, they were presented in a yearly basis, something significant. Now they are presenting something significant every week or even every day. So yes, we are in the merge of big change. But then, how it is in the healthcare sector, the development is actually still on the linear curve. We are just piling paper on top of each other. If we think about, I'm now doing this comparison with this analog interface. If we think about linear development, it's something that we pile paper on top of each other, and then of course we increase the pile, but then it takes quite a lot of time. But what if it would be the exponential development curve? So if we want to make a 1 meter height of pile of papers, it takes actually 10,000 of these, 0.1 millimeter thick, and then A4 sized. But the exponential growth, if it would be starting to fold the paper, okay? One fold, A5 size, 0.2 millimeters. Now it's A6 size, 0.4 millimeters. Okay, that's not so impressive, but if I continue to make these folds, so what do you think, how many folds it takes to reach 1 kilometer height? If I could make the folds, or how many folds to reach the moon? Now you're thinking processors are scrolling, but I made the math for you. Only after 24 folds, we reach the 1 kilometer mark. Only after 42 folds, we reach the 480,000 kilometer, 384,000 kilometers, and that's more than the moon. So think about that. That is the exponential growth. And that is the key why healthcare sectors should collaborate with technology companies to bring these huge superpowers of quantum computing and other technology in the good use in healthcare sector. And how we do it in Oulu? We do it through ecosystem activity. We utilize Oulu Health Ecosystem. There are the research and innovation resources from the University of Oulu, Technical Research Center of Finland. Then we have these health and social care providers, public healthcare like our organization, but also private healthcare providers. And then, of course, these several health and life science companies within the region. One of the maybe most recognition is Oura. You might know the Oura Ring. The idea and innovation is from Oulu, nowadays run from the United States, but still the product development is located in Oulu. The ecosystem is run by Business Oulu. Minna Komu is here today as a network director. Jenni Konttila also doing great work there. And together we make these things happen and run this public-private collaboration. And let's not forget the citizens. They are at the center of the activity. All these efforts are provided for the better care for the citizens. And if we take a look at the map, Oulu is not the capital of Finland. We are actually quite remotely located. We are, from the European perspective, we are just in the periphery. But Oulu is just the right-sized city for the health technology development. And the collaboration between partners, it's easy, it's like natural, and we have this can-do attitude. And as a recognition to that, Oulu was actually ranked in the top 30 places for health tech startups in the world. There are places like San Francisco, Stockholm, Paris, and then Oulu. So quite proud of this achievement. And then let's move into this Oulu Health Labs topic. That is the innovation platform in healthcare operations where we can actually test the solutions already in the development phase. I've been happy to hear these comments before that listen to end users. That was really well stated by you. And also, when we listen to end users, they can bring these, of course, usability feedback for the product development, but they can also bring in their ideas to be further refined and then created into these radical health innovations. Oulu Health Labs, in the concrete manners, it's an ensemble of actors. Oulu's test lab in the university hospital, then primary care, social care and the elderly care by Pohde Wellbeing Lab, then future professionals by Oulu University Applied Sciences, and then world-class medical imaging training and testing resources from the MIT Lab. And together we can provide this opportunity for health companies, health tech companies, service companies to bring your idea to us or bring your prototype to us or even bring your ready product to us. So we will collect those healthcare professionals and refine and give feedback and make sure that this innovation can be refined further for the better results. Of course, it's the meeting of different worlds. There is different pace in the public healthcare traditionally, and then these startups companies with the really tight schedules and limited funding. So that is something where we need interface agents. Also, the language is not the same. We are actually speaking healthcare and the companies might be speaking health tech or technology. So there needs to be someone who is actually making these co-creation sessions happen and then follow the process and ensure that the communication is happening. One of the recent examples of our test cases is the Medicubex. It's the e-health station where the patient can actually measure all the vital signs needed for the basic health check by themselves. So this is an innovation that frees time from the healthcare professionals, and then when they meet the patient, they can actually focus on talking and meeting the patient and not just doing something on the computer and making the measurements. This is a really promising health tech startup in Finland, and we have been happy to be able to run this trial use of it in the acute reception of Oulu University Hospital. Actually, it was in the primary care of City of Oulu. And then further, what is coming up, we see that robotics it's coming. We have been able to test those telepresence robots, social robots, and various logistics robots. What I would like to state here that these robots in the social interaction, you shouldn't put them down. Actually, when we have collected the feedback from the children and from the elderly, they are quite happy to be able to communicate with the social robot. Because robots are always there for you, and they have all the time in the world to listen your topic, not just listening and then scrolling Instagram and YouTube and whatever. So that is something that has huge potential in the future. And then when we test something in the Oulu Health Labs, we can also provide feedback for the companies, and then for the best solutions that fill the criteria, we can provide them the Oulu Health Labs quality label. It's not the official standardization or something like a medical device regulation field, but that's the quality stamp evaluated by us. The other side of the story are the ideas from the healthcare professionals or from the citizens. We have an open channel continuously for these ideas. We collect ideas, we collect development needs from the professionals and from the citizens. And that's happened through the electronic idea management platform Orchidea. And the best of those needs that we recognize, we can actually take to the co-creation path. And this model of operation has been developed in the EU-funded in-demand project. It's been validated by the University of Oulu, and it's been tested in Finland, France, and Spain. And one of the examples here is the NE device developed Vitacam solution, which is the contactless respiratory rate monitor. The big thing here is that the need was real from the emergency room nurse. The technology company was not a medical device company before, but they evolved in the project. And the timeline from the need indication to the ready medical device, certified medical device, a little bit more than 2 years. So this is the revolution. This is different from the typical time frame of 5 to 7 years of developing a medical device. And this is something that we can do again. In the steps forward, we know that this AI is something that it's really hype at the moment. But also, we have been now reaching the technology readiness of these natural language processing models that can actually perform the tasks that we now want them to do. And like Veera presented yesterday, the great example from the Länsi-Uusimaa. So now the similar development is actually happening in Pohde with a little bit different technology solution and with our patient data management system provider, ESCO Systems. And also yesterday we talked a lot about biodesign. I'm happy to tell that Oulu is on board, and now it's the first round of biodesign that we have been involved, and great support from Aalto University in that. And that is something that is really good way of recognizing the real needs in the healthcare operation. And then only 2 words about the future hospital, but it's still something that I'm really proud of. It's the renewal project, 1.6 billion euro investment in total. Oulu University Hospital is being built, renewed and rebuilt on its current stand. And there, it's not a construction project only, but it's actually the way how we operate that's been renewed. And only then, when we know the new processes, we select the technologies needed and build the facilities that are needed for this new operation. And the D-Day for the start of the new hospital is on the 6th of November, so that's really soon. And there also we are utilizing the latest technologies in the infrastructure, like a first ever private 5G network in the operating hospital in Europe. This is something that is enabling a platform for the future health technology development. In here, we are utilizing it to run wearable solutions to bring better condensed information for the medical professionals. But it's open platform for further development, and would be happy to share more about that and discuss about that with you. And then one more, the last point is that Oyster is the future research development innovation center, which will be located next to the smartest hospital in the world. The first concrete part of the Oyster is this Oyster incubator, which has had the flying start, and I've been also happy to be part of the activities that they have been arranging. But there will be more, so keep in mind that Oyster is something that happens in Oulu. Running out of time, so not too much time for challenges. Only one. The big obstacle that we are facing is the cultural change that is needed. It's really easy to stick in the old habits. Technology that can be brought in, but if you're not changing the mode of operation, you are still stuck in the old habits. And there, I was happy to hear yesterday from Veera this Be Brave. So that is a really good way of starting this new path. Like I did something great last year, I did my first 100 miles trail run. So that was something that I did not know if it was possible, that I just took the first step and then continued on the path. So when you are developing something new, be brave, know where you're going, vision setting, target setting, that's crucial, and don't ever accept the first no. So with that, I could end my presentation. Thank you.
Thank you, Timo. And I know that you are in a hurry you have to catch a plane shortly, and unfortunately you are not able to join our panel, but I will have 2 questions for you. You mentioned the cultural change, but how do you see, what are the most important key factors for increasing this collaboration through partnerships and innovation actions to partnerships?
Good question. I think one of the key things is, it's been mentioned many times, but this demand-driven approach. So to know the real needs and then select the technology that can solve the need. So that's the way how we can actually speed up the process. Other thing is that this resourcing, it's a real challenge in public healthcare at the moment. Yesterday we talked with Sara, I don't know where Sara is, but there is a chance of applying these innovative procurement methods. We should, as a nation, we should use money for innovative procurement, and that is one way of solving this challenge. And also these research cases that we have been doing together with HUS, for example. So when we do great research and development application for EU level, so then we get decent resources for the further development. And then we can also involve companies in those.
Yes, I agree. You mentioned innovative procurement, but how do you see, is it easy to find partners for your innovative projects?
In almost in every case, yes. It's been really, really easy. Of course, there are some limitations when we are operating for in real patient interface. So there needs to be these permissions in place, and then that might be the hindering thing. And also when we are discussing about AI development, so this model training with the real patient data, that is a challenge. So mostly the challenge is not about finding the technology partner, but it's about going through this hurdle of rules and regulations related to this privacy and security issues.
Great. Thank you once again, Timo, and I will let you go. And then we will have a presentation from Rohin Rashad. Hopefully I presented that right. He's a Director of Innovations from Novo Nordisk, Japan.
No, this is good. Well done on the pronunciation of the name, by the way. That was spot on. Hello, everyone. My name is Rohin Roshan. I come from Novo Nordisk, Japan, and then you might think, did you fly all the way from Japan to Helsinki? No, I did not. I'm currently in Copenhagen for a couple of months, so that explains why. Yeah, no, I think some inspirational talks from the sort of colleagues, so to say. Novo Nordisk, I promise I'm not going to talk about Ozempic today, right? So this is going to be about design. It's going to be health innovation. The title of the talk is, Can Pharma Play a Sincere Role in Advancing the State of Healthcare? And I think before going into the details, the reason why we put the word sincere, and I think that's quite important, is that often private companies, they always have a commercial agenda, right? And I think we should be transparent around that. For private companies to partner up with healthcare stakeholders, sincerity is sort of one of the critical success factors. Now, share a little bit more about that later, but this is super important. I think it's also important to say that pharma companies, we speak a lot about this term beyond the pill. Again, this is quite vague. Most of the times we're talking adherence apps, et cetera, but I'm really keen on sharing a story with you of what we achieved in Danish healthcare that was truly, in fact, beyond the pill, and it drove really good health outcomes. And we saw great effects among healthcare professionals. We worked with topics such as burnout, organizational excellence, and health outcomes at the same time. Now, before I share that story with you, I want to go sort of into a very personal aspect and share my resilience score. I actually have an Oura ring, and I have been a big fan of Oura and in general Finnish technology for many years. I want to draw a comparison between healthcare and heart rate variability. How many in here measure their heart rate variability on a daily basis? Yeah, got a few. So long story short, heart rate variability has been there for many decades, right? And it's not until recently where we're trying to use that data point to show the resilience of an individual, or sort of depict the autonomous nervous system of an individual, to sort of show how much can this person take on of load or exertion on any given day, or stress, you could say. And I want to share with you, so about a month ago, I relocated to Japan, and we're also expecting a baby, and my wife is sort of late in her pregnancy, so she couldn't travel with me. And I'm just going to share with you here, and it's quite interesting. If we can show the, you can see I started quite strong, right? And then around early September, this is like my first day in the office in Japan. September 1, I'm like dying basically here at this point. And then things started going better. And the reason why I'm trying to draw this comparison is essentially, if we look at healthcare, the sort of uniform challenges you see across the globe is there's huge demand for healthcare services. This, if you're repeating ourselves many times, aging population, chronic disease prevalence, but it's equally also about awareness and health capital. Most of us are more curious around our health, and we go to our doctors with our wearable data. We want blood work done every 3 months. All this is really increasing the demand for healthcare services. Now, at the same time, we are utterly limited in terms of resource, both hands and heads, but also money, funding. The whole funding model is still quite challenged. Most of the time it's publicly funded. In other cases, you have private insurance companies. They're just as strict as the public payers. And this sort of brings us to a context of too high of a load and literally no recovery for a healthcare sector. Very much like my state in early September. I was dealing with a lot of stuff, packing up, going to a new country, very different country, at the same time leaving my wife in Denmark. There's a lot of thoughts, and I couldn't necessarily put on more stress on my body. That is very much, I would say, how I would describe the healthcare sector in a global context, is that it's constantly in a fight or flight mode. We're putting off fire every single day, whether it's primary care or secondary care. There's no time to actually rest and digest. And it is in the time of rest and digest that we actually develop. This is where our physiological state or mental state actually gets better. And there's no time for this in healthcare. And I was part of the biodesign program in Copenhagen, biomedical design with Susan Pernille, and we shadowed healthcare providers, and independent of the specialty, the domain, it was the same thing. There's no time to get new insights. There's no time to develop. There's no time to innovate. Healthcare providers go to congresses less than they've ever done before. Then there's just also too much noise. All pharma companies, including Novo Nordisk, maybe also Novartis, I'm not going to point fingers, but we all, we flood you with information. You don't have time to digest it, right? So this is like an evil spiral of downward trajectory. The operators of healthcare, in return, they need to partner up. I mean, it is sort of alpha omega for the ones operating healthcare, whether you're in primary care, secondary care, you need to partner up externally to solve for things you cannot solve yourself. And if we take the pharma point of view, I mean, this is what you typically associate with pharma. I haven't been long in the pharma industry, but you know, in general, what you see over on the left-hand side, that's like a pharmaceutical sales rep. That still exists till to this, this day. We walk around knocking on doors, and then we try to sort of give 3 key messages to doctors and nurses, trying to push them to prescribe a product. And it's not very charming. It's sort of a major turnoff. Then we're really good at developing adherence apps, right? Adherence is sort of a clinical mental model. Not a lot of patients, it doesn't resonate with them really. I mean, life stands in the way of adherence at times. And then, you have shows like Dopesick showing how Purdue Pharma operated their business. This is not, not necessarily, when you come with like this type of baggage with you, whether you're a healthcare provider or a government institution, whatever, you're not necessarily, coming with the best of context for partnership. But I do also want to say that pharma is also full of these kinds of people. Now, just in Novo Nordisk, we have plenty of medical doctors that have practiced before. We have a lot of nurses, people who've studied pharmacy. People understand the innate needs of healthcare, and they all have sincere ambitions to make that healthcare sector better. That's often why they joined the pharmaceutical company. They understand the needs of HCPs and patients. Now, I want to share with you the sort of innovation model that we apply in my team, and that sort of we developed from the ground up, very much inspired by the biodesign methodology. Now, I'll share with you this shortly, and then I'll share a quite interesting project we did in Denmark, where we developed a decision support tool for primary care physicians. Now, this is not rocket science. It's very basic. I think the most difficult part about this process is more the discipline of actually doing the things we talk about doing in design, because that's where often there's a discrepancy between the textbook and the practice, right? Now, the first one, explore the needs and validate, GOOTB, and Seuss is laughing there because this is a practice that, we learned at that program, get out of the building. And I really apply this till this day, getting out of the building. There's so many things that keep us stuck to the desks at the offices, so many meetings, a lot of bureaucracy, a lot of excuses to not go out there and talk to the real people. And this is really a muscle you need to develop within your organizations to really get out there and understand the needs. And then obviously there's a robust validation process tied closely to that needs exploration for you to understand what should I work on. Then I cannot understate the importance of interdisciplinary teams. You really need the skills of or at least the right skills across the team to develop what you're doing. And then co-design is something that we do by standards. And when I say co-design, we invite healthcare providers, we invite patients in, for instance, in a whole week design sprint. We bring them in for a whole week, and then they're part of designing the solution. And what you get out of that is not only listening to them and understanding their need, you also get ambassadorship and adoption from the get-go, because by the time you're done with the solution, you already have some users that understand it quite rigorously, and they're also ready to use it and talk about it with their peers, which, by the way, peer-to-peer sharing in healthcare is probably the strongest way of building adoption. Then I won't spend too much time on rapid prototyping, but the thing I've highlighted in red, user testing, again, something that we talk about in textbooks, but it really requires testing and discipline to keep bringing your solution out there to the users and get that feedback. It's quite uncomfortable at times also, because you'll get negative feedback. And again, building that muscle within your organizations to almost enjoy that negative feedback. That's like part of the success criteria of moving forward. This really is a huge change management exercise. And then the rest is sort of, it says itself, build the product if it makes sense, involve some key opinion leaders to really spread the word around this. The next thing I want to share with you, and it's quite interesting that the previous talk was talking about getting rid of paper. We in fact did this project, and we do a lot of innovative stuff at Novo Nordisk. We run AI projects. We're building all sorts of cool digital things. But this project was actually a paper-based decision support tool. And this goes back to, again, design is an agnostic methodology. Often when we talk about design or new, there's almost like a predisposed decision, it has to be digital. Well, not always. In fact, sometimes something analog can also get the job done. This is a risk stratification tool for managing type 2 diabetes. What we discovered exploring needs in the Danish healthcare sector is there's a task shifting happening in healthcare, and it's happening across the board, but specific to diabetes, a lot of physicians are handing over critical tasks and managing the condition to nursing staff. And nurses, any nurses in the room? 1, 2? And I'm not gonna, put people in boxes, but from my understanding, nurses really like concrete guidelines and concrete sort of, tell me what I need to do in 10 steps, and then I'll do that. If there's any sort of element of, outside that box, that's quite uncomfortable for nursing staff, at least in a clinical workflow. One task that in Denmark, doctors had handed over to nurses was risk stratification. And what does that mean? That means we assess the risk of a patient, and then we put them in some sort of treatment path. And that decision was very difficult for nurses. So what we did was work with the leading KOLs within primary care and also endocrinology in Denmark, and we developed a framework on how to do this in less than 5 minutes. And that's what you see here. There's sort of some schematics around the most important data points and decisions to be made within diabetes. And then you might sit and think, well, holy shit, is that really what you had to present, a paper-based product? But honestly, we went out and tested this in thousands of clinics in Denmark. This is data coming from 40 clinics specifically where we had access to their databases. And it shows two very important things. One, you're seeing quite a steep adoption of the tool. That means already there you have product market fit of some sort. People are actually using it in a clinical workflow, and they keep using it, and it makes sense for them. So that's quite important. Two is on the right-hand side, what you see in yellow and red are patients that are perhaps not receiving the treatment that they should, according to their status of the disease. Now, we talk a lot around driving health outcomes and prevention, et cetera. This is data showing that the tool actually enabled identification of patients at risk of developing comorbidities. And what's also very important with nurses in primary care is once they've identified a risk, they're much better than doctors at acting. So treating aggressively happens sort of much faster with a nursing staff once they've identified a risk, whereas a doctor can be slightly laid back at times to say, well, we'll just look at that in 6 months or 12 months, whatever. Now, what we also did after that was we had this in mind from the beginning. Building a tool like this, we're navigating in an evidence-based environment. We can't just bring tools or decision support tools without any kind of sort of evidence or data or validation. And just for your information, we started this project about 2.5 years ago, and just a few months ago, we actually did a publication in the Journal of Diabetes Epidemiology and Management stating the effect of this tool. Again, a fairly simple paper-based tool that was designed through the methodologies of design thinking and co-design. Novo Nordisk, a pharmaceutical company, working with healthcare providers in Denmark and government institutions. We have a publication out there that sort of states the effect of this has nothing to do with our products, has nothing to do with Ozempic or any of the other things. It has to do with supporting healthcare in sincere efforts and innovating healthcare for the better. And we're quite proud of this. If I were to just share 3 key takeaways, and then I'm done, is one, partnerships are necessary to move the needle. It has to be established on sincerity. So for us, as a pharmaceutical company, it's very important to sort of sometimes let go of some of the commercial stuff, right? Here, we're interested in patients being treated better. Of course, there's a link between that and our products. We have the most innovative products out there, but we're actually just trying to solve a problem in healthcare. 2, co-design is absolutely possible, although healthcare professionals are quite busy and they don't have 10, 15 minutes to spare. But if you are actually trying to solve a problem that is very critical to them, they'll spend a whole week with you. And we have this as a proof and many other projects where they just step in and participate in a sprint for a whole week. And then finally, we're working in an evidence-based environment. Have this in mind when you do anything of this nature. Have a plan to show the effect in a validated scientific way. That'll definitely get you further along. And that's it. Yeah.
Thank you. Thank you, Rowan, for your insightful presentation. And next, I'm happy to welcome here on stage Martin Magelund Rasmussen, who is the Director of the Center of Head and Orthopedics at Rigshospitalet, Denmark.
Well, thank you very much, and thank you for the invitation. It's correct. I have a CEO responsibility for one part of Rigshospitalet. I'm also part of the board of management, deputy chief executive. And basically everything has been said already. And then again, my perspective will be on a more systemic level, and how we at Rigshospitalet has tried to approach co-creation and partnerships to be able to solve some of the things that we've heard already. Thank you for great speeches from all my colleagues. Well, you probably... Is it on, this one? Okay. You probably all know Denmark from, we bicycle a lot, the Little Mermaid. And then we have a long tradition of building our wealth on agriculture. We don't have a lot of natural resources. And all that agriculture actually has then moved into a very strong life science sector. And I just want to, just a little bit of a word on how that has happened, because I do think there's something about our culture that is beneficial for all of us in the Nordic countries. And this is this cooperative movement that was initiated almost 200 years ago, and where you have had a very high level of trust among everybody, where you actually knew that you had to work together to be able to create more. When the peasants 150 years ago went together and said we need to do things together to be able to be more efficient and have a strong voice, then they agreed that every man should count one vote and not how much land they had or how much cattle they had. I mean, there's something about leveraging out the playing field that has created some of the large companies that we have in Denmark and also across the Nordic countries, and also some of the way that we look about how we drive large companies. So the foundations is an integral part of this. And I believe that this culture way of thinking is one of those that is going to help us in the years to come to cope with some of the challenges. And we all know that one. We have to do more for less. That's basically what it says. 2 or 3 speakers have already been into this, but it's we're very aware of that everywhere when you go into a hospital, that is the task. And if you talk to the employees, they would say, but how do we do that? We already run And I always say to them, you don't have to run anymore, you need to find out how to do this smarter. And then they say, but we can't because we have all those guidelines. And then tell them, well, drop the guidelines and do what you think is the right thing to do as a professional. So we have to utilize the energy that we have in the systems. So just a few words on Rigshospitalet, the oldest hospital and largest in Denmark. You see 1.2 million patients a year, a lot of research, all medical specialties and all that. So we claim to be good. I would say that one of the things that we've been working on over the last couple of years is how do we actually look upon ourselves, and how do people look upon us? How do our partners and fellow hospitals in Denmark and also internationally look upon us? And they all said we were very good, but we were also very aware that we were very good, so we were not very good at reaching out. So our new vision for Rigshospitalet is to benefit the individual patient, and we've always done that. But then the second part is, and the overall healthcare system. And it sounds pretty, well, of course. But when you start thinking about it, what does that entail? Because that actually entails that sometimes you should stop treat. Sometimes you shouldn't do what you think is right, but you actually reach out and do what is right for the patient at where they are, at a local hospital or at a community. So it's changing our way of thinking, and thus the cultural road that Timo was talking about. The second part of it was that we also enlarged our working portfolio, if you will. We always worked with treatments and research and training education. It's part of the core task at hospitals. But we added one, so we now have innovation as a fourth core task. And again, it's just a small word, and well, we're already doing innovation, people say, yeah. But if you think about it, that is suddenly go from 3 to 4 core tasks, so that every department, every unit has to figure out how do they encompass innovation as part of their daily operations. Then most of them will be challenged. But that's what we do. We say we have to move innovation all the way into the core of running our business. So it means we have to find out structures, responsibilities, all the same things as we have for treatment, as we have for research and education. And I think that's going to be a driving engine in the years to come of how we can change faster, because the acceleration that was mentioned is needed, otherwise we can't cope. We got 4 strategies in the vision: value for the patient, connectedness, empowerment, and internationalization. I'm going to only talk about 2 of those because time is running, and we also have to have the panel debate. But this one about empowerment, I'm back to the point that there's a strain of literature that tells us that 75 to 85% of our employees tell us that they can do more if they were allowed. So how do you actually make people allowed to do more? Well, you need to tell them that that's their responsibility. And it's also a strain of literature saying that when you take the responsibility and you also do your own decisions, actually you have a happier work life. You actually stay longer at the same work time. Even though you work harder and you do more and you're very tired when you get home, but you got the control over your work life. So it's quite important that you actually empower all these people. And by doing that, you also say that the management level have to give off power. And that's a new way of thinking, at least in Denmark, where it's very hierarchical. You know, decisions always go upwards because somebody at the end, in the top, needs to take the decisions. We need to put that triangle the other way around. And we have been working for that for quite some years. And it's difficult, and most people will say, yeah, well, they look happy, these ones, but they also run fast. And that's true. We have to have employees being happy, running fast, because we have to do more for less. And then we have a whole strategy for partnerships and cooperation. And we put a specific focus on internationalization. As Denmark is a very small country, but I think it counts for most of countries in the world, we need to reach out. And we are very quick in getting in love with our own projects, our own way of thinking. So actually reaching out is an essential part. And the best one to promote that reaching out is actually partnering up. Partnering up with large international corporations like Novo Nordisk and others, who can actually have knowledge travel even faster than we have. In public institutions, it's very difficult to scale. It's very difficult to have information moving across. Just within our own hospital it's difficult. Even let it be between hospitals in Denmark, or even let it be across nations. So we need to put that around and say, okay, who can actually help us see what we do good or what we could improve? Well, you need to have partners there who is out there in the market and can actually help us. So our innovation journey in short has been, 10 years ago we did all these small innovation competitions, trying to lure out, saying there must be things that we can do in operations that we can do better. And we did. Then 5 years ago we said, let's try to establish an innovation center to able to get a little bit more scale on what we are doing. And it grew pretty fast. I think there were 40 people within a couple of years. But then again, it was kind of living on the side of the organization. So last year we said, well, we're going to dismantle the center and then we're going to embed it in all our functions. And you said that was in the mission of the organization. And of course that entails a lot of development of our own management, clinical management, and at the same time internally in our staff, they also need to do it. That's why Erasmus, which some of you was listening to yesterday, is part of that. So actually the mindset about whatever you do, whether you're in accounting or whether you're in HR, you need to know what innovation does for the organization. And the next jump on that will be the strategic integrated partnerships. And it comes in many forms, but one of the important thing for us here is that they are actually long-term. I mean, we're talking partnerships and collaborations over 10, 15 years. It's not one project over half a year or a year. We're talking long-time commitment from us and from the partner that we're partnering up with. And it comes from corporations all at each the level out at each ward or each department, and it also comes in clinical areas, and some of them comes across the whole hospital. And those has to be the driver for the rest of the change. So we're doing quite a lot of work right now to see how do we actually partner up with large international corporations, and not just telling them that now we do 4 projects together with 4 project lines and 4 nurses or doctors who are really eager on those, but actually trying to turn it around and say, what kind of long-term objective or impact do we need to achieve? We don't have to read all this, but it's just basically just utilizing an impact framework that is a very old tool, has been used ever since the 60s, but we've kind of forgotten because we always start down there and say, what kind of projects do we need to do together? So when we do a project, we think we have a partnership. Not in my view, not in our view. We think we have to focus on where do we want to end in 10, 15 years. And we spend a lot of painful time down there, because if you agree where you want to end up, and then you deduct down and you say, okay, in the shorter term, and what kind of output do we need, and what kind of things do we then need to utilize? Then you suddenly end up doing other projects than the normal product lines. You suddenly end up having people in the room from both R&D and sales and various divisions at the hospital, and then suddenly magic happens, because we cannot pick the winners. We have to get out a mechanism that is continuously trying to promote these new interactions. And these interactions will be then spinning off good ideas, and some of them will be products, and some of them will be processes, and some will develop us to be able to do more. And this is the way we try to work with all the large companies. So focusing on the long-term impact. Let me just have a few examples of what we're thinking about, and it's a leap into the future. This is Thomas. He's a head dentist here at our hospital, and he actually worked with Johnson & Johnson and a Belgian firm called Materialise for like 15 years, trying to develop software to be able to planning for surgery. And this has helped us not just improve productivity and efficiency at the OR about 120%. We can do like 1.5, 1.6, even more operations per day. And we have also managed to get down infections. We do 1 operation instead of 4. So it's a golden egg there, but it takes 15 years. Now we got 3 or 4 of engineers embedded in our organizations from the private organizations doing that planning. It's not healthcare professionals, it's other professions. This is Jens. Jens is living with a chronic disease. He's at home. And that's also the way we're going to treat patients in the future. We have with the load coming in, a lot of people have to stay at home. A lot of people want to stay at home. Actually, they get better by being at home. But doing all the monitoring and doing all the numbers and doing all the things so the doctors can actually be proactive, we need a lot of monitoring. So we have a lot of projects going on right now trying to figure out how do we actually get the right vital signs in there. Not easy at all, and some of you have mentioned it already. You can measure everything, but how do you measure the right thing? But that's also where we're going to need each other, because we will not be able to run these kind of things. We also need to integrate more on a digital part. We all have our systems and 15, 10 years long contracts, but we need to open those to be able to have third-party products coming in. That's also something that we work with. And then we need to have these efficient and sustainable hospitals. And the whole sustainability issue is actually pretty important for us. Sustainability is not just about CO2 footprint. It's also there. We need to work with that. But it's also about how do we actually get a shift in the competence in our workforce. Right now we have maybe 95% of all our workforce is healthcare professionals. I foresee that in 10, 15 years, we will be down to 80%, and 20% will be people with another technical background. So we made an integrated partnership with our technical university in Denmark, in Copenhagen, which has happened to be the best in Europe. And they actually do a lot of life science, both education and research, and they've had a hard time getting into the hospitals because we kind of, cultural-wise, it's technical. We know that we need technologies and digitalization, and we think that we can learn it by ourselves, but getting those professionals into the myth of our patient pathways, that makes magic. So we're going to have thousands of these kind of engineering students coming into the hospitals. We're going to have joint professorships, we're going to have associate professorships. The long-term commitment that will change healthcare, because we cannot choose the winners, but we can choose the people that work with us. And that will make magic, I'm quite sure. With Beta Health already, another vehicle for trying to unleash some of the things that goes on internally at the hospitals. Won't drill with that. Rasmus was saying that yesterday, but it's also a success nationally. So it's been taken on by other hospitals, and now we're making a second program round, which is going to maybe increase the program by 10 to 15-fold. Very excited about that. Then we have a more national level. How do we try to underpin all these things that we want to do? The Danish government, together with our community in Copenhagen and also the region and the hospital, have pointed out an Innovation District Copenhagen. It's a completely copy by Kendall Square thinking. But I mean, getting out some of these ideas that will also leverage financing, will leverage some of the focus can be actually on Copenhagen. That is some of the ideas that we need to do. And then, we also have been supported by the government, and they have had a life science strategy for the last 3, 4, 5 years, and now the next one is coming out. And look what it says: focus on partnerships. Also say there's more investment needed and all that. We all know that. But this focus on partnerships is there to be, and we need to have it in the long run, because otherwise it won't be viable. So we have an ecosystem that looks like everybody else's: industry, universities, hospitals, government, investment funds. And I'm not think we should coordinate all of that. It has to be out there somehow, but we need to figure out when they overlap, how do we get those overlap to work even better. And in the end, acceleration. We need to figure out how we have a lot quicker impact than we have now. So every time we do these things, it's with a view of how do we accelerate change and how to accelerate impact. So to sum up, innovation as a fourth core task at the hospital, especially here at Rigshospitalet, we think it has a huge potential. You need to work multidisciplinary, and collaborations with the private actors are absolutely necessary. And then we do think that it might have also potential transformative impact, not just in Denmark, but across the Nordics, across Europe, across the world. Then we also have a point saying we also need to focus on implementation, because even though we have this driver for change, we need to make people very good at actually adopting change. That's where some of the initiatives with the DTU and our management comes in. So we need to mature our management to be able to take on these new tasks. Very important. And then the internationalization, like being here, talking to you. It's important to get out there, talk about it, get a new view of how you do things, because we have a tendency to be able to invent the same wheel over and over and over again. So we need to join up. And then we need acceleration. Thank you.
Thank you, Martin. And now I think it's time for our panel, so please, I would like to invite Pinja and Royen back to the stage. So we will have a short panel discussion before the lunch. Okay, so we all know the challenges we have today, at the moment and recently, which infect the innovation, but I'm very happy that all of you had your presentations quite positive. But just to highlight, what would you say, what are the most important factors to increase innovations through partnerships? Maybe Martin, you had the mic.
Well, actually, I think you had one point up in your slide saying something about sincerity. I think this level of trust needs to be increased. I mean, we have to get out of the bubble thinking that it's not fine, or you need you can have your hands get dirty by working with private. We need in the public sector to realize that we can only succeed by actually joining these kind of forces, as there's so much power, so much knowledge that's not been utilized because we are kind of hiding away between barriers that is made by others. So we need to break down those barriers.
I completely agree, and I think it was really interesting when you showed about kind of staying in the problem space in the beginning, because I think that's where trust is built. If we can stay there long enough, everyone knows kind of what is the shared goal and what does everyone benefit from the partnerships. I think that's where we need to stay more. But I think it's also about what we've been talking about, kind of new capabilities. I think we shouldn't stay in the problem space with the kind of usual point of view. I think we need to already there have new capabilities involved. And for example, design being one of them, kind of looking the problem from a different angle.
Yeah, and I agree with that, obviously. And if I were to add something on top of that, probably an exercise of signal processing is also needed. We need to be super sharp. There's a lot of noise. There's a lot of new technologies out there. There's also a lot of problems. So what do we solve first? What has most impact? So, usually in healthcare, you have something, as fundamental as health technology assessments, HTAs. So when something new comes in healthcare, whether it's a new pharmaceutical product or a medical device, you try to sort of measure the impact of that. And perhaps we should have some signal processing on the problems we're trying to solve as well. So that we're super sharp in the partnerships. What are we trying to solve for? So it doesn't just become a public affairs messaging kind of a thing. Yeah.
Thanks. And question for Martin. Now that Timo need to leave, so you're the only one representing hospital side, what kind of concrete needs do your hospital have now or in near future that could be solved through different kind of innovations, and how do you see the collaboration? Is it easy to find partners in these innovation activities?
It's easy to find partners. I don't think that's a problem. I mean, as a public employee and utilizing the taxpayers' money, there's something about competition and how do you leverage procurement and these kind of things. But we need to put that a little bit away, and then we need to focus on where do we move the organization. There's a lot of need there. I mean, obviously one of the greatest one is to keep patients out of the hospitals. So keeping the people at home is probably the major point when you look upon the demographics that we're looking into. So how do we actually scale those engines that we can still monitor, we can still make people safe and feel that they are close to the doctors and the nurses they need, but they're not in hospitals. I think there's a huge driver there for change. And then you can, pick down an individual kind of smaller problems. But I think that is the most overcharging problem that we have. And everybody's trying to solve that. So that's where we just systemic approach. They're saying, okay, should we all, use the same forces to solve the same problem, or should we go more together? How do we actually get that also cross-national cooperation? Because most of the projects I hear about has somewhat the same kind of flavor. So there's really a coordination issue that we need to deal with.
And then question to Pinja and Rohan, how do you see the situation from the private company perspective? Is it easy to collaborate with public sector or to find these projects or to fulfill these needs?
I think it's both. I think if we have a clear common problem, then it's usually, that makes it a lot easier. But also at the same time, coming from a pharmaceutical company and the slide you had of kind of the old school image that people might have, for example, about pharmaceutical companies, we have baggage. So that's something that we have to kind of overcome every time we want to form a partnership. And that's exactly also why I say that we need to stay kind of creating the common goal first, because that's the only way to get through that barrier.
Yeah, and perhaps I want to highlight two things. The first one is, again, as a pharma company, when you engage with a healthcare provider, there are some very strict guidelines on how you do that. So in Denmark, for instance, There's really two things by definition you can do. One is disease awareness, or the other one is promotion, so marketing, right? And so coming from the innovation team, we'd like to do other stuff beyond that. And neither the regulators understand that, even our own leadership may not understand it, and the other side of the table, the healthcare providers, don't expect it either. So there's some fundamental stuff that's not in place. Then there's often also some misaligned incentives. So if you take secondary care in Denmark, there's definitely at the hospital level a strong motivation to keep patients at home, try to optimize resources, not have that many consultations in the clinic as such. But then in primary care, you might have the opposite incentives. You know, these are individual businesses. These are entrepreneurs, business owners, the general practitioner. And in some cases, they actually want patients to come in because every time you swipe that insurance card, there's a fee-for-service system that accommodates that. So aligning on those incentives, I think, would be an ask from my side that at a public level, have we structured the healthcare sector in such a way that we're all working towards the same goal, or are they sometimes working against each other?
Yes, and continuing question, Pinja, we have a lot of regional collaboration here in Finland in healthcare sector. How do you see it? Should we increase the national collaboration or international collaboration? How do you see it?
Well, I think definitely we need to increase it. I think it's not, well, to be fair, the reform is quite recent, and I know there's been a lot of energy put into just putting the structures in place, but I think the next step, natural step, would be to increase the cooperation between the regions at the moment. So I think we have a long way ahead of us, but a lot of potential also. And what we see also, for example, from our project with these being services counties, that everyone is eager to share. I think we need some kind of structure and more national guidance around that.
Yes, I agree. And what about Martin and Ryan? Do you have some kind of insights that we could learn from you, from something from abroad that we could bring here in Finland? What should we do better?
I don't know if I'm the right one to give you any good advices. I actually like your old system. It was like the incentives basically were there to do prevention, and I think you have less of that incentive now, but we have the same system that you have. I think there's something about, I think actually legislation-wise, I think we are moving, and I can hear that so are you, and our new reform will also improve something about the GPs and incentive structure. But I think we actually, maybe instead of giving good advice, say we need to join forces about how do we utilize the very good registers we have across the Nordic countries. Because suddenly we would then be a total market of 25 million or 30 million people instead of being 5 independent markets. I think there's something about joining forces across that could benefit the whole region and our patient group, because suddenly we would be a larger factor also for investing in all kinds of funds, the European Union, the VCs, the big companies. So there's something about joining forces that we should do a lot better at both legislation level and also at institutional level.
So I can only echo that, especially when it comes to new groundbreaking technologies, whether you're setting up a supercomputer, quantum computer, whatever, right? Then there's definitely some knowledge sharing that can happen cross-regionally. I also think at the same time, healthcare is a very local thing. So there's some local dynamics that are not scalable as such. That's why companies like Apple, Amazon, and Google, they've all failed a little bit, at that sort of downstream activities of healthcare. But I think on the upstream activities, there's really opportunities to partner internationally as well. Yeah.
Great, thank you. And just one more quick question and short answers, please. We all know that Christmas is coming soon and Santa is from Finland. So what would you wish from the Santa Claus so that we could improve innovations and partnerships?
I think this is probably a common theme. needs-led innovation is probably what ties everybody together. That would be the wish from here.
I believe in Santa Claus, so I'm asking for courage. I think we need to be brave to do things differently, really. Now's the time.
Well, keep believing and share more.
Great. Nobody asked money, but thank you. I think we have short time. Maybe if you have some questions
let's
from
take
the audience.
some questions from the audience. Yes, madam. Let me just... Over.
Thank you. My name is Susanne Kavalko. I'm leading and consulting our EU-level research and innovation activities at Helsinki University Hospital. Thank you for our interesting panel discussion. I was missing one thing, which is really something I'm very interested in, and that is environmental sustainability. You did touch upon the healthcare system sustainability in many ways from your interventions, but I know that the healthcare sector has a lot of things we could do quite easily to also bring some change in the environmental matters. I know the companies, the big pharma, the big tech companies, many are very keen on starting to collaborate with, for example, hospitals on these matters. So any thoughts how we could accelerate this stuff on our own, but also collaboratively, for example, on the Nordic level? Thank you.
I actually think it's a very important point, and I had one slide about sustainable hospitals, and I was focusing on the workforce. But on the other, we're actually trying to develop metrics to be able to actually also to measure what is our burden and how should we ease it. Because if we can make that measurement all the way down to the individual unit, it's very difficult to drive change. We need those data, and they're too weak today. So one of the innovations should be to put down those microdata on each individual consumption level, basically, to be able to drive the change. Then I have another bottom line that I can serve apart from patients, and then I also need to serve that bottom line. But right now, it's a difficult incentive structure as there's no figures on operational level to be able to make change. So it's in the awareness, but putting it into daily operations, there's a lack there, and we need to develop that. Hopefully, some of these things we're talking about could make that faster.
Yeah, sure. I think there's a shared responsibility around sustainability from an environmental point of view. So the industry can design their drug delivery products in such a way that it's environmentally friendly. The hospitals can work more sort of proactively around disposable products, etc. I think perhaps if I could challenge it a little bit, sometimes our very sort of CO2 focus can sometimes also make us very short-sighted. If we take AI as an example, in the very short term, AI has become a huge energy consumer, right? That brings a dilemma. What do you do, right? Do you leverage the great technologies that it could bring with it, the synergies? We're building all these data centers, data ecosystems, but then we can't really leverage all that data if we don't have groundbreaking AI to sort of analyze that. So there's also some dilemmas out there. So, and then we can see things sort of naturally come about. So the whole nuclear wave now, all the tech companies purchasing long contracts on nuclear energy as a way of supporting that wave. Sometimes this discussion can make us a little bit short-sighted, whereas some opportunities lie. So yeah.
And I think it's also about like how do we measure this, for example, in our partnerships. And I think the good side of the digitalization and patients, for example, being at home is also the positive sustainability aspect of people not having to travel and being able to be treated at home. So I think we need to look at more holistically also when we create new ways of working.
Just want to add, I think also that we need to get down to the really brutal discussion about where should we not treat and where is the damage larger. And we haven't got to that point yet. So I don't know whether that's the same thing you're touching upon, but there's also something about treatments that we develop that is way too costly to the amount of people that it actually helps compared to with the damage it does. And we don't dare to take that discussion, but it will become there in the next 20, 30 years. It's not us, then our children will take it. But if we are responsible, we should start taking that discussion.
Another question, because I have a question. Does anyone else have a question here? Yes, over here.
Thank you. So you mentioned that need-driven innovation is what ties everyone together. And I also kind of seen that different stakeholders in the healthcare system speak different languages, so to say. How do we make sure that the way that we approach these are tailored to them so that we can actually speak one language and drive the need-driven innovation?
My favorite topic. Because as a service designer, I think one of the key things is the visualization piece. When we define the problem, we need to visualize it so that we kind of get the understanding that everyone is talking about the same thing. Because many times, for example, in our partnerships and projects, we have found out at some point when we put together all the insights and we kind of visualize the problem, that many people have assumed that some of the fundamental, even words in our discussions have meant different things. So I think and that also links back to me being a parrot and saying all the time, stay in that problem space, but I think that's the key thing to make sure that everyone is talking about the same thing.
I will ask a question. So going back to Martin's picture with all of the circles and the different partners, so if you think about building a partnership or consortia, you've got very different types of organizations that run at different clock speeds. And they're also doing their day jobs as well as going into a partnership. So is there a way that we can maybe use more AI to auto-generate and remove some of the friction when we're building these partnerships, and then also to report on the results as well?
Probably, but I'm not sure we're going to necessarily need to apply an AI tool to do that.
Problem solved. None. Okay, any more questions?
But actually, it's an interesting question, because sometimes we do want to solve things with the most complicated way of solving it. Mm. And I'm not quite sure that's the way we should solve it. I think we should open our doors a bit more to be able to have humans actually meeting each other. Because getting that interaction among humans, sometimes magic happens, instead of us being instrumentalized by somebody else who tells us what to do. And I could be a little bit worried about having, all kind of things telling me what I should do. I would probably get a little bit offended by it or something. So I do think that we need to have a more open door policy and need to actually focus on those common denominators for success. And then we need to talk about what not to do.
Very good. Time for one more? Going. Hey, let's big round of applause for our fantastic panel here and the questions as well. And especially to our wonderful host as well. So now it's lunch, and we're going to come back in, I think, 20 to 2 for the pitching, and then after that, it's the main event in the afternoon. Thank you very much. Hey.
So I guess the atmosphere is getting a bit thicker because there's the pitching competition final is about to start. But before we do that, I would like to a little bit introduce the people who have helped to organize the pitching competition and also the organizations behind the whole event. So my name is Otto Olavinen. I'm the main organizer of the health design and also for the pitching competition. And it's been very wonderful to spend the time with you through these 2 days, and I'm very excited to see what happens in the competition. First, I would like to ask maybe Christian Lardot, can you maybe tell a few words about the Health Incubator Helsinki, which is a very important organization in the startup space in Finland?
Yes, so my name is Christian Lardot, and I'm heading the Health Incubator Helsinki. And first I would like to thank Otto for the 5th year putting together this program. It's a wonder man doing all this by himself. It's really very good, and let's give him some applause. And so a couple of words of Health Incubator Helsinki. So we have been operating the incubator since 2020. So far we have had 50 companies in the program, 30 alumni and 20 companies now active. The companies can be in the program for 3 years, and then you could ask, so what's the benefit of a startup to be in an incubator? The key benefits are our network that we can provide investors, consultants, industry experts, and then network also outside of Finland. And the other one is in incubators, as you know, usually you have this peer-to-peer support. And then one thing that our companies have said that is really beneficial for them is this public, that we write stuff in LinkedIn, on our webpage and so forth. So it's part of a bigger umbrella which helps these startups. And so far, 40 million euros these companies have received in funding since 2021, which is really, really nice. Okay, thank you.
Thank you, Christian. And can I round of applause to Christian once more? And can I have Alexandra from Terco?
Hi everyone, I'm Alexandra and I represent Terco Health Hub. We are a hub for health and life science entrepreneurship located in Meilahti campus, and we are funded by the University of Helsinki and Helsinki University Hospital. We've been around from 2017 and we currently have 72 companies under our roof. Many of them were pitching yesterday or pitching today. And super happy if you want to talk to me during the networking break and see what we could do for you. We suggest tailored approach to all the companies. We have partners that provide free or discounted services to you. We have investor connections. We are very well connected in the ecosystem, and we are quite cheap. We welcome R2B projects as well if you want to become a part of the community. And you can also use our offices and co-working area 24/7. So you can talk to me.
Thank you. Round of applause. And next one is Mika Miettinen from Fiban, who is one of the main organizers also of the pitching.
Super. Thank you very much, Otto, and happy to be here. And thanks for organizing the event. It's super, super nice to have these kinds of vertical specific events, which is one of our key activities at Fiban as well. Fiban is one of the biggest angel organizations in the world. We have more than 600 angel investors and about 24 or maybe 15 or something VC partners and CVC partners as well, together with whom we invest more than 20 million euros every year into early stage startups. So super happy to see also these great companies and yesterday's great companies here. I'm quite proud actually of the achievements of the companies here so far, and I hope I can facilitate the opportunity for those companies to find relevant investors today and in the future as well. So if you're an investor and you need good deal flow, I'm the person to talk to, and if you're a startup who needs good investors, I'm the person to talk to, and I'll try and do everything I can to facilitate opportunities for you. Thank you.
Thank you. Thank you, Mika. Pratek, would you like to say a few words?
Thanks, Otto. Hi, guys. Today, you will see most of the investors are either really big angels like Kusta or really good VCs. But I still see, as a founder myself, there's a big difference between investors' expectations and what the founders should really have prepared. So I started investing since last year through a few funds, Lifespan and Focal in US and UK. And this summer I joined Hustle Fund, who were the first investors in Webflow and Figma. And from there, I'm trying to deploy a little bit of my own savings and then also getting startups ready for these really good investments. Thank you, Otto.
Thank you, Prateek. And then Kustaa Piha.
Okay, hello everyone. My name is Kustaa Piha, and I'm here as a business angel. And it's super cool to be here. And a few words about myself, what I do look for. I have a medical background and a serial entrepreneurial background in healthcare services, building companies from 0 to 100 million euros in turnover. So I try to find companies which I can help. So I cannot take all the problems away from the entrepreneurs, but as an entrepreneur myself, I know some ideas how to solve them.
Thank you, Kustaa. So next up is the Investor Life Science, Marko Kuisma.
All right, thank you. I'm so glad to see so many of you here. It's an important and impactful topic. I'm Marko Kuisma. I'm a partner at Innovestors Life Science Fund. We're a venture capital fund based here in Helsinki. We invest in early stage drug development and digital health, and we're very keen on life-saving science. So we love science-backed companies with evidence, with a solid evidence base. And as an early stage investor, we invest in companies from anywhere from company creation up to about Series A, with tickets ranging from 250K up to about 4 million as our entry ticket. So very excited to be here and looking forward to the company pitches. Thank you.
Thank you. And next one, Matti from Nordic Science Investments.
Thank you. Great to see everyone. Hi, my name is Matti Hautsalo. I'm from NSI, Nordic Science Investments. We're one of the newest funds in Nordics, and we collaborate closely with the tech transfer offices of the universities. We are ecosystem specialists working heavily on life sciences, but we also invest in physical sciences. Our team, we have a researcher, tech transfer, BC, and investment banker, so we hope to cover the ground very well. And the most important thing about us is that we want to get more science-based companies up and running. We are willing to go there very, very early. The earlier the better is almost better for us, because we think that too many companies actually die before they're born when they get in Finland out of the R2B pipeline and no one is there to catch them up. So talk to us also if you don't feel you're quite investable yet. We might still think that there's a runway to be built for you. Thanks.
Thank you. And next our international VC, so Yun from Hadean Ventures, please.
Hi, nice to meet you all. I'm Yun, analyst at Hadean Ventures. So we're a venture capital firm based in Oslo, Norway, with a second office in Stockholm, Sweden. But really we have a geographic focus in the Nordics, including Finland, because we think it tends to be underventured. So really good to be here. We have around 250 million euro under management. The second fund is roughly 150 million euro. Halfway through, still in a very active investment mode. So yeah, let's connect and explore synergies. Thank you.
Thank you, Yun. And next is Fiorella from Nina Capital.
Hi, nice to meet you all. I'm Fiorella from Nina Capital. I come as an analyst. We are a venture capital firm specialized in healthcare. Sweet spot actually between healthcare and technology. So anything that includes computational data, we love to look at. We come at the pre-seed and seed stage, and we have international sort of ambitions. So founders that have a local focus, but also willing to expand. That's also a great thing that we look at. And first entry ticket between 150 to 1.5 million. So we're also quite early and super excited to be here.
Thank you.
So now let's begin. So our first pitch today, as you see on the presentation there, is Smart PD solution. So please, the floor is yours. And so we have 5 minutes for the pitch, and then there's 2 minutes for questions, and then we change the pitch. Yep.
So, 1 out of 10 is the number of people suffering from some kind of a loss of kidney function. It is called chronic kidney disease, CKD. In the final stages of CKD, you end up in a dialysis treatment just to stay alive. This CKD is uncurable, so we can only slow it down, but we cannot cure it unless we get a kidney transplant. Problems? Yes. So one of the most natural treatments, dialysis treatments, is peritoneal dialysis. It is the most natural one, and this treatment is usually done by the patients, by themselves at home during the nights. But there also lies the challenge. You are home alone with a treatment that is very demanding. So our solution, patented solution, is our monitoring device. It can be connected to any dialysis setup at home, and it detects life-threatening infections, and also by using biosensors, it's able to collect data from the treatment. So we are able to optimize the treatment to be personalized and be the best for that exact patient. We see that this is also the platform for future dialysis management. So we are collecting data that has not been collected earlier. And this data can be used really to bring the dialysis to today. Is this a business? Well, yes. In US, where we are aiming, it's a 2.3 billion business, and we aim to be 140 million revenue company by the end of 2031. And we are already walking this path. So we have gathered almost 700,000 already, and we are now looking 2 million round to get us to the next 2 years, to develop our device and our company. So what does the 140 million look like? It does not mean that we have to get everybody to use our solution. It means that only less than 6% will use our solution. Little bit over 20,000 users in US. And it means in practice 1 service provider for PD treatments in the US. Our business model is to build the cassettes. The cassettes are disposables. So every time during the night when the measurements is taken, new cassette is needed. Our competitors, we identify them, but we are the most lab-like solution at home. And it is proven and accepted technology that we will use. Our team has the knowledge, expertise, and connections to make this happen. Management team is backed up by research PhDs, and our advisory board has people behind Synlab, Baxter, and HUS. So, what we are doing is improve lives and reduce healthcare costs, making dialysis safe and accessible for all. So join us. Come to talk to us. We will give you the numbers, the science, and show you that this is really the case to be involved. I'm Juha Remal from Smart PD Solution.
Thank you very much for the presentation. Can you tell me a little bit more about the competition and competitive situation right now?
So basically, at the moment, we identified 2 competitors that are coming to the markets. They are applying for the FDAs, and they are using new technology, for example, ultrasound, to detect the white blood cells. But we are using optics, proven technology by camera and calculating those white blood cells. And we use the golden standard compared to our competitors. So we also look the cloudiness of the liquid, count the white blood cells, and also ask symptoms from the patient.
Do you have estimates on the revenues from these competitors and what has been the adoption rate of their platform?
They are so in early stages that we do not have access to that data yet.
You build the cassettes, the disposable cassettes.
Yes.
What happens to the data?
The data is transferred to cloud, and there we store it, and then we can use it.
So it's yours?
Yeah, it's our, yes.
Do you plan to monetize on that data as well?
Yes, I believe the data will be the really big thing, because we are collecting data from treatment that has not been done earlier to optimize it, make it better. So also the equipment manufacturers are interested about the data, how to make the dialysis treatment better for the patients.
And so you mentioned that the data previously wasn't being collected. So now, what is the use of that, and how are you going to make sure that the healthcare staff are able to use it?
At the moment, healthcare is collecting the data once or twice per year from patient. Patient has to go to the clinic, give the samples, and they do the lab tests. But now we can collect the same data from every treatment cycle. So data points for IA are much more, and also we are using the same methodology that they use in clinics. So we do not introduce anything new for them clinics. So yes, we believe that they will accept this quite easily.
Okay, that's it. Perfect timing. So, round of applause. So the next is Surgerix, and Patrick here will raise the hand when there is 1 minute left. He's there on the left. So.
Okay. I'm Paavo Vartiainen from University of Eastern Finland, and I'm here to tell you about Surgerix. Surgerix is software for safer and faster microsurgical operations. In these operations, surgeons look at the tissue through microscope and endoscopic cameras, typically 2 cameras in one operation, and they need to follow the video streams on screens or oculars. This leads to ergonomical problem because they need to switch their attention between the different video streams. Further problems are narrow and deep surgical openings, where instruments block part of the surgeon's field of view, which leads to workflow interruptions. We have developed a patent-pending software which combines these 2 or more video streams into one unified video stream. And our solution makes instruments transparent and can also augment highly zoomed microscope view with a wider view. The market we are entering is estimated a $10 billion market by the time we enter market. And in practice, there is about 24 million single surgical operations where our solution may be relevantly used. About the competitors, the microscope and endoscope are the conventional solution. Integrated endoscope refers to state-of-the-art product by size, but even that doesn't have math-based image processing as our solution has. It's basically picture-in-picture solution. And double ocular microscope is a hardware solution for 2 video streams. In our business model, we aim to sell software license so that the cost for the customer is about €100 of their working day. And if our solution can save, for example, 10 minutes out of 1.5 hour surgical operation, the saving is easily $1,000 a day. In our preclinical study, we have demonstrated our solution to 16 surgeons of 4 nationalities and collected feedback systematically, and also personally in Finnish Neurosurgical Society days. So benefits are less risk of surgical errors thanks to better visibility and shortened operation time, which leads also to faster recovery of the surgical wounds and improved cognitive ergonomics for surgeons. Our roadmap includes establishing a company next year and entering clinical markets in Europe, US, and Japan. Our team features neurosurgeon Ahmed from Egypt, who is working as clinical instructor at Kuopio University Hospital, and our research to business process is guided by 2 professors with previous experience and led by Mikko with software business experience. Our advisors include chief neurosurgeon from University Hospital, clinical neurosurgeon and ENT surgeon, and Tamar and Visa as medtech professionals, and we are using consultants to tackle the regulations. Right now we are looking for investors to join our pre-seed round, which is 1.5 million round for our 1.5 year, within which we will set up our quality management system, most importantly. So please contact us to join our journey. Thanks for your attention.
Hi, thanks very much. When you go and get the clinics to adopt your system, you mentioned that you have the surgical training centers. Is that something only for the beginning, or how do you see in the future, how will they adopt your technology, which obviously needs to be extremely well proven?
Yeah, training centers are good and important customer group in the beginning, because there are about 1,500 of them globally, and they are of course good in that sense that surgeons learn to use our solution there, but maybe for the software license model, training centers are not that good customers. They may maybe want to buy it as one lump sum.
Thank you. I was wondering in terms of the clinical evidence that you need to generate, can you talk a bit more about your plan on that and the parameters around safety, around ergonomics, reduced time? What are your thoughts on that?
Yes, of course we need to prove the 2 main benefits, the reduced time and reduced risk of errors. And the reduced risk of errors, we are building simulation setups so that how wide field of view a user can perceive during the operation, and for the time saving, of course, comparative simulations are needed.
So who are you selling to? Are you selling directly to the hospitals, or are you selling to manufacturers that have robotic or surgical equipment?
Our plan is to sell to healthcare operators. Of course, it differs from country to country. Who pays the bill? But the surgeon's opinion is, at least in Finland and Europe, surgeon's opinion weighs a lot when they decide which hardware and software is bought to operating rooms.
Thank you.
Thanks, Paavo. Video fusion has been quite established for augmented reality trading purposes, for example, in aviation industry. So how defensible is your solution?
Yes. In medical domain, we have not noticed that this kind of fusing of various video stream has been done, but it's true that it's done in has been done in a few other areas.
Thank you, and once again, round of applause to Searcherix. Yeah. So next, Sebastian from Polku Therapeutics.
Hello everyone, my name is Sebastian Soidinsalo. I'm from Polku Therapeutics, I'm the operational director. We are developing new therapies for Parkinson's and Alzheimer's disease in order to stop or reverse progression of the disease. I can do that again with more flamboyant demeanor. Hello everyone, my name is Sebastian Soidinsalo. I'm from Polku Therapeutics, the operational director there, and we're developing new therapies for Alzheimer's disease and Parkinson's disease in order to stop or reverse the progression of the pathology. The brain, it's an amazing organ. Within it is the ability to solve complex problems like math, to be able to feel emotions like love, or basically the ability to move around. So in this 1 kilogram of fat and protein really lies the essence of what it is to be a human being. But it's also very fragile. So when things go wrong, when we lose our neurons, we're also losing a part of ourselves. Imagine waking up and you're grabbing your morning coffee and you spill it. That's basically what happens in Parkinson's disease. Your hand is moving too much or isn't moving at all. Or when you go to your coffee shop and you can't find your place home, that's basically what happens when you have dementia and you lose your spatial memory. So in neurodegeneration, that's the overarching word describing these pathologies, we have some loss of neurons in the brain. And one of the underlying phenomena is protein aggregation. So we have these pathological proteins, alpha-synuclein and tau, that form protein aggregates that are toxic to the neurons. And the problem in current therapies is that they're not really addressing the underlying cause of the pathology, but rather they are symptomatic. So there are no available therapies that slow or stop the progression in these diseases. The market, there are around 2.5 million patients in Europe and US. For Parkinson's disease and for Alzheimer's, there's around 15 million patients. And I think it's important to draw some parallel to other markets. So if we think about multiple sclerosis, it's about the same size as Parkinson's disease, but the leading therapy on that market, Ocrevus, is selling at 6 billion a year. So if we would have a disease-modifying therapy in Parkinson's disease, the market would not be 8 billion, it would be twice that much, because even a single asset can reap revenues about the size of the current Parkinson's market. And I talked about protein aggregation. There are two mechanisms by which the body can alleviate this. So there's autophagy, where the cell can process these aggregates and basically take these clumps and break them apart and metabolize them. And then there's also phosphorylation, which increases the potential of these proteins to aggregate. So by removing phosphorylation, we actually remove the potential to form new aggregates. So what we're trying to develop is a therapy that would increase the cell's ability to process these aggregates and also decrease the ability of these proteins to aggregate to begin with. So we would inhibit new aggregates from forming, but also reduce already formed aggregates. And that could lead to reversing, potentially, the symptoms. Behind our program is a discovery that an enzyme called PrEP has another binding site. So the enzyme is not only an enzyme, but it regulates other things in the body. And by modulating these interactions, we can influence these processes. So by modulating the interaction with PP2A, we increase the autophagy in the cells, and also by modulating the interaction with alpha-synuclein, which is one of the important pathological aggregates, we reduce their dimerization, which is the aggregation potential. In a Parkinson's animal model, we introduced a lesion to the other side of the brain, where the mice would only be able to use, or they would prefer to use only one of the hands. And when we use our therapy on these mice, they actually use both of their hands. So they don't have a preference on using either hand. So that is kind of a proxy for alleviating the pathology in the hemisphere where we introduced the lesion. I promised to talk about the Alzheimer's model. So this is testing the spatial memory of mice. So in wild-type mice, they would like to go outside of open areas.
You have 30 seconds.
30 seconds. So open areas because they're afraid of predators. So they would go to their hiding place. In this disc, one of the holes is a hiding place. But if they have this Alzheimer-like pathology in the brain, they look around and don't find the hiding place. So it's the same as not finding home from the coffee shop. And when we treat these mice, they again have normal spatial memory, and they learn to find their hiding place. So we have a team with a professor of pharmacology from University of Helsinki, and Simon Bennett is our CEO, and we are on our way to raise a 5 million seed round. Thanks a lot.
Thanks, Sebastian. Good pitch. But we have seen really fantastic results in animal models. How do you foresee translation to human studies, and which has been a very big pitfall in most of these CNS therapies?
Yeah, I mean, obviously cannot promise success in human trials, but the thing is that there are good hypotheses that need to be tested in people. So ultimately, yes, there are drawbacks within the mouse models, but it's widely recognized that these protein aggregates play an important role also in people, the tau and in Alzheimer's and alpha-synuclein in Parkinson's. So the hypothesis has not properly been tested. If you reduce these aggregates in the human brain, what happens in patients? One big problem there is that the patients are diagnosed quite late in the pathology, so most of the damage has already been occurred when we test the clinical trials. So maybe other ways to run the clinical trials earlier in the disease process are needed.
Do you have any safety issues arise from these animal tests, and do you give it as an injection or oral supplement?
So our aim is to develop a orally bioavailable compound. That is the target product profile. But currently our tool compounds have been IP administered, so not orally administered. And yeah, toxicity, we have not found toxicity in our current animal models, but we haven't really tested for it either. But that is something that we can also optimize once we know the mechanisms, if any toxicity arises.
Yeah.
How much is left on your preclinical path, and where does the 5 million take you?
30 seconds.
How far does 5 million take us? It should take us on the verge of starting IND-enabling studies. So we hope to at least have covered the lead optimization stage by that.
Thank you, Polku Therapeutics. And next up is Otos. Oh yes, okay, good. Multitasking.
All right, the rest of the presentations are about ears because it turns out they're really important. So, I'm Wycliffe from Otos, and we're working on integrating hearing care into primary care for early detection and early action for hearing loss. As we discussed yesterday, a quarter of the global population having hearing loss by 2050, up from 1 in 5 people right now. 80% going undiagnosed, and it's costing us $1 trillion globally. We heard how important the brain is. Turns out hearing is really important for cognitive health as well. So Susie here has had hearing loss for a while. 9 years later than she needs to go, on average, is when the patient goes to get their hearing check. Goes, multiple visits to the doctor. They have difficulty interpreting the results that come in when they come for their analysis. And 7 to 10 months down the line, she finally gets into specialized care. They have trouble making sense of all the information, have to rerun a lot of these tests. And the motivation of the patient is not known necessarily towards the end of this. So all this could have been for nothing if they don't want to do anything about it. So we're really simplifying this pathway. Speaking to customers in the US, they want faster, more accurate turnarounds on the results. So we created a system that diagnoses twice as fast and is more comfortable for the patient and also for the clinician. They want to spend less time and effort doing the analysis. So we generated a system that delivers gold standard level results by a layman, and the doctor could process these in minutes instead of hours. And of course, it has to be cheap. All of the before mentioned makes it cheaper, but it's also always better to integrate into the healthcare systems so we have a seamless treatment path and actionable results. All of this taking us 75% less time. So minutes versus hours, it means we can have more patients come in, approximately 5x more patients. When you look at primary care, we're trying to incentivize primary care to do these tests. So one of our systems fully kitted could be generating 25K after all expenses for primary care. They have the incentive to do the tests. People are coming in early. Specialized care is having a much lower customer acquisition cost, 10% of what it used to be. So we're kind of playing these dual networks over here. Costs go down, sales up, better quality outcomes for the patients as well. Sorry. All right. Yes, so we have a great team to make this happen. Tanya over here is our globetrotter and has been managing international stakeholders, and she's going to be leading our operations. Saku and Ville have a lot of experience in the industry, and they have been coming onto their second decade in hearing healthcare. Myself, I'll be taking the CEO role, and my background is in medical devices. I've been working on medical devices in Philips and Covercare for multiple years. Also startup experience with Hyperion, where we've raised money and have been growing the company quite well. And I am particularly proud of the gentlemen we have from the US on our advisory board, because that is our go-to market, and we're talking to them to really understand what is needed over there to make this a reality. We're going to be making money mostly based on our software, the subscriptions. Device sales are going to be incentivized by the consumables. So distributors are not just selling a device, they're selling a device that's going to be generating more revenue for them. So really trying to incentivize our distributors to get on board with this. And launching is going to be the first part where we start becoming profitable after all our pilots. And we're going to be scaling globally after the US and releasing our next generation product that's supposed to be even more profitable, getting into cognitive health. So we want to pilot as much as we can here in Finland. We want to go to the US. That's going to be our 510K approval to the US, launch over there, and then circle back to Europe after that. There is a lot of competition.
1 minute.
Apple being the big bad wolf on the block entering this space. But what we really aim to do, we aim to be the primary solution when it comes to hearing diagnostics in primary care. That's where we catch hearing loss for the first time, direct patients to either the specialized or over-the-counter side for hearing care. We've got 700,000 in funding running out the end of this year, so we're spinning out of the university. We talk to patients, have an investigational device based on our quality management system. We're running clinical trials, planning our second ones. We have the patent and FINMA approval to do the clinical test that we've been doing so far. And to go to market in the US, we need 1 million to grow the team and start turning our product into a reality, and also working on the next generation platform for autos. Thank you very much. I'll be happy to have your questions.
Thanks.
Yeah, Apple made a pretty surprising jump into this. And I think for them, where they have been pushing the Apple smart wearables, for example, the watches, also in clinical trials, how do you see competing against such a behemoth?
So I don't see we're competing against Apple. So what Apple has actually done, they're bringing more awareness. So what they're doing in their OTC hearing aids, over the counter, is that what the OTC stands for. Plus, there's been a lot of other players in this space. That's going to get you from mild to moderate hearing loss. Once you start getting into the more profound side, or you need more processing capability, you're going to have to go for this prescription hearing aids. And also, that's just going to raise awareness and bring people to the clinic earlier. What we really want to do is to integrate the hearing care into primary care. So the hearing health is something that your doctor should know about, and not only Apple.
What's your plan to achieve the FDA 510K approval? And second question, why do you select the US as the first market to go?
So the plan for the 510K approval, our clinical study, we've been comparing to the gold standard. So that's going to be enabling us, giving some leverage to have a predicate device based on what we've been comparing to. And what part of our hardware is class 1, so that's going to make it slightly easier to get in there. And the partner we're working on with audiometry, they just actually got their FDA clearance recently. So that's going to make it a bit easier for us to get into the market.
So you're bringing this to primary care. I think there's going to be a learning curve in terms of you placing this to a GP's office. How much have you gathered sort of intel on that and sort of feedback in terms of whether they're open to that, and do you expect to face resistance from the primary physicians who would sort of need to start doing this?
Yeah. So what we want to do is we want to make it really simple. And when you look at any audiometer out there, you have options. We're removing options. We're doing the audiometry and endoscopy. It's a really straightforward thing. It should be actually not the doctor who's doing the test. The doctor is interpreting the results. They're going to be getting assistance for that in the beginning. But it should be the easiest to do hearing test that gets most clinical accurate results for further down the line for the patients. So really focus on 13 user interface clicks to get the results in front of the doctors.
Is it all in the software, or do you have an edge and IPR in the hardware?
So we have IPR on the hardware side mostly, and we're exploring if we can get some more with the system and method patents for some of the software elements that we're having.
Thank you. And thank you, Otos and Wycliffe.
Good afternoon. I'm Tuomas Klokkars and I'm from Sibbo Medical Devices. We are a company based in East Helsinki, and there's at the moment 4 persons working in the company. What we do is medical devices based on cameras and AI. We do hardware and AI. And here you can see our hardware. We have at the moment 4 devices, 1 to check the ears, 1 for nose and mouth, 1 for throat, and then also dizziness goggles. All our devices share the same principle. It's basically a camera which uses a smartphone or tablet with our user interface. We have sold devices to 8 different countries. Total sales so far is a bit more than 100K, which is pretty good considering that the otoscope has been on the market for a bit more than a year, and the 3 other devices came to the market this August. So we're doing pretty good. Compared to current devices, our devices are far, far, far smaller. They all fit to a shoebox, compared to the current device, which is kind of size of a fridge. We've put a lot of effort to the ease of use, to the design. These are really kind of intuitive. You don't need to have any kind of education to use these devices. The users are both doctors, specialists, and nurses. One thing is also that telemedicine is coming by storm, and we've taken it kind of from the scratch that these are telemedicine suitable, especially teleconsultations. So it's easy to send information from place 1 to place 2. When we founded the company, we knew right from the beginning that it's not going to only be hardware. We've been concentrating on AI also. We have a library of 3,000 different ear images, all classified by 7 different specialists. We have done a screening tool. Kind of the idea is that the nurse checks the ears, the AI tells if the ear is normal. If the ear is not normal, the patient is referred to a doctor. At the moment, our sensitivity for abnormal ears is 96%, which is far better than any doctor in any studies so far. We have the AI ready, and we are here trying to get money for the CE marking. So the benefits. Benefits are pretty obvious. As I said, 96% is better than any doctor. So we get better diagnostics. Better diagnostics always makes more, also better savings, and it saves work, time, and money from the user, the AI. Just as an example, more than 1/3 of ear examinations in US are done by nurses. So not doctors, nurses, and then the nurses consult their doctors. Could you imagine the market size for a device which should make these consultations easy? Or if the machine would have AI, so you wouldn't actually need to consult the doctor. But the machine is there 50 meters from here, so you are welcome to come and check it after the pitch. For the AI, the idea is to have the paper analysis model, which should be pretty good looking at the numbers. We are looking for 400,000 to 600,000, and mainly the reason is to get the AI, CE, and FDA regulated. Happy to get any questions.
It's a two-part question. So first, are the AI results published in the peer-reviewed committee? And hardware manufacturing, especially for endoscopy, it has been becoming quite generalized today. So are you competing on price or uniqueness? What's the angle there?
Good questions. About the research. About the research, we have ongoing a research project with Helsinki University Hospital. The 96% is based on our own validation set. I've got no reason to believe that it wouldn't be true, but as I said, they are actually going studies at the moment with the Helsinki University Hospital. So we kind of have also a objective validation for that. About the endoscopies, yeah, basically when we talk about cameras this size, there's kind of 2 proper manufacturers in the world, and we are using the other one. So cameras, everybody is using the same cameras. It's the design, it's the ease of use, the design, the functionality. Rather than concentrating on cameras, I would say that we are concentrating on the ecosystem. It's not just the ear otoscope, it's not just the endoscope. You kind of you have multiple devices which you all use the same way, which makes it a lot easier.
One question about this AI, what's the time to market with that if you get the funding?
Jani could answer that better. I'd say 1 year.
And another question is about the pricing of the current solution you have in the shoe-sized box. How much does it cost for the clinician?
The whole shoe, I mean, the box is there. Unfortunately, I didn't take it on a stage, but all our devices go to this small box, and we sell the whole box, including the box, for 3,500 euros. The fridge size kind of a thing costs something between 20,000 and 30,000 euros. So we are a lot more affordable. At the moment, devices which we are kind of making are used only by specialists. The whole idea is to make them more affordable, easier to use, more intuitive, so that every doctor, every nurse could basically be using them.
I was wondering, you have a suite of different sort of techs, devices. Is there any specific one that you see it's most valuable? And a different question is, as you scale, what do you think your defensible moat will be? The second question? Yeah. As you scale, what do you think your defensible moat will be?
Yeah, I'm not sure if I understood. I don't speak startup. I'm a clinician. The first one, which is most valuable? I personally love hardware. That's because I use hardware in my everyday life. But to be honest, the kind of a biggest thing is going to be the AI. We have already the AI for the ear diagnostics. The dizziness diagnostics is on the pipeline. So basically, we can kind of do it again and again. Yeah, I didn't get the second question. That's my mistake, so sorry about that. Competition. Yeah, competition. There's a lot of competition. It depends a bit what you look at. There's no such company who does the same panel as we do. Hardware, AI, ear, nose and throat diagnostics. So no direct competition, but a lot of competition otherwise. Yeah.
Okay, that's it for the time. Thank you so much, Thomas, and thanks, Sibo. And that's it for the pitching competition. We will soon start a panel on pediatric and maternal innovation. And we will hear sometime in the evening from the jury, like we aim to be before 5, but it seems how much time the jury needs, so we'll take that. Thanks. We'll start 5 past.
We start 10 past, actually, 10 past.
And we also have other initiatives, for example, a couple of R2D projects.
Se jotenkin.
Siis niitä ei se hae.
Janine will hear it, right? Okay. Kyllä. Joo. Okay. Can you, Janine, try again?
Sure. Hello, how are you guys doing?
Good.
You can hear me now?
And do you hear the microphone? Do you hear this? Do you hear? Jos ihmiset esittää tästä, hänen pitää kuulla se paneeli tehdä. Sullahan on tuonne tulee. Jatka.
Testing, 1, 2, 3.
Kuuluuko sinne? Can you hear with the microphone? Janine, can you hear the microphone? Can you hear the microphone, Janine? No? No sound?
Hear me? I can read lips, but I cannot hear you.
Cannot hear the microphone, no. Cannot hear, no.
That's helpful, but everybody is muted on my screen, so I'm not sure if that's part of the issue.
Laita sulla mikki pastaa. Kuuluuko nyt? Did you hear something, Janine?
Sorry, you can't be there in person, otherwise we wouldn't be having this issue.
1, 2. Kokeillaan Håkan vielä. Kuuleeko nyt? Ei kierrä. Tehdään niin, että laitetaan vaikka rapparissa tehtyä, koska Janin tulee siitä
This is less than ideal, but if you can hear me, I can present. And then someone can, maybe if you just unmute yourself and someone can come up to the computer and ask a question or something along those lines when it's time for that. Oh, that would be great. And hopefully I'll be able to hear something. And if I can't, then come over, because I don't want you to have to spend a lot of time doing that. This needs to be there in person next year.
Thank you for the fantastic startups with their pitching. Thank you to the investors for their insightful questions. We're now into our final session, and it's going to be hosted, actually, chaired by the wonderful Otto, and it's going to be focused on pediatric and maternal innovation. And we have a fantastic panel, both here in the room and also online. So, Otto, please take it away.
Thank you all, and we had to be a bit innovative to come up with ad hoc solution how Janine can hear us. So I will use the laptop mic to communicate with Janine, and the panelists will do the same. So let's see how it goes. Okay. Let's start. So let me introduce our wonderful first speaker. So she's Janine Fuerk. She's a medical doctor, and she's a clinical associate professor of pediatrics at Stanford University. And she's also part of the Biodesign Stanford program, and also she's co-lead for the Impact One health network. So Janine, the floor is yours.
Thank you so much. Such a pleasure to virtually be there. Hopefully in the future I can actually be there. I know we have potential plans to do that. So I can't see all of you, but always feel free to shout out with questions, and I know there'll be time afterwards too. So this is a little teaser. I know you've been hearing probably a lot about adult medicine, and that usually excludes women's health and pediatrics, unfortunately. But we're here to talk to you about the wonderful fields, the amazing opportunities, and get you hopefully a little excited about that. First, I'll probably start with how challenging it is, though. So, of course, I'm one of the assistant directors of the Innovation Fellowship and took that myself at Stanford Biodesign and deeply entrenched there. We just had some rebranding that we went through with a new donor, but we truly believe in these values. And so we think it's important to show these every single time where we talk about the fact that this is a team sport, that we really do this by learning how to collaborate and have empathy and promote leadership within all of our own fellows and that as well. So we do that through education, innovation, and policy. So I know you guys know this a little bit because I heard you've been hearing a little bit about, biodesign programs and certainly Biodesign Finland. But most of what happens in university academic settings and in many settings is you develop an innovative technology and then you try to find the need for that. And of course, biodesign flips this completely on their head, and it's more of a need pull. So we really believe in deeply understanding the need, and then the technology almost invents itself, not quite, but it certainly does then make it a lot easier to develop a technology that will ultimately lead to adoption. I find this to be particularly helpful in pediatrics, where you really have to be incredibly streamlined. Of course, this is the biodesign process at work, identifying the secret sauce. What is the real clinical need? Identifying a lot of them and screening down to the most compelling unmet clinical need. Then, yes. Can you not see it? No. Okay, I'm on screen sharing on your computer, and it says you are screen sharing.
Can you do it again? Just try again.
Sure. I'm so sorry. I'm talking to you guys this whole time. Let's try again. Could you see it before?
We saw it before. Yeah.
When I. Okay. You see it? Yeah. Oh, that's weird. Exact same as before. Yeah. Okay. Well, that sounds good. Can you still see it?
Yeah.
All good? Okay. Well, I'll just clicking through things. Not important. So this is where I was talking about the biodesign process at work, really understanding this clinical need, developing a disruptive technology around that. And where I think we really have to work in pediatrics especially is, of course, crystallizing that need, but where we've been able to really come up with some creative solutions are around building a viable business. So people often look to pediatrics as a space that is filled with philanthropy, and maybe the company should be sourced in that way. However, I firmly believe that you still have to have a viable business to be able to sustain whatever technology you've developed, to be able to get that consistently to patients in a safe manner. So, Biodesign loves to tout, at Stanford especially, that, over its 20+ year history, that they've helped over 13 million. But the really sad part was up until a few years ago, the number helped of pediatric patients was actually only about 14,000. And that's because the process, the way that it's typically done, often selects for larger markets as opposed to smaller markets. And we've begun to change that at Biodesign as well. And this is a slide I frequently show because I think it's really important for people to understand the decisions we're making. So industry truly spends more money to develop health technologies that address the last month of life than on technologies for the first 18 years of life that can really transform a lifetime. And to me, that just means we have our priorities in the wrong place. When we say that children are a small population, they really are 25% of the population. So it's actually not that small. And as James Wall always says, they are 100% of our future. So something to consider. But all of this translates. And so I'm showing this from a US perspective to give you that insight. But from the US FDA, the approvals over the last several years have really been stagnant. So the pediatric approvals are down there on those blue boxes, and adult approvals, and this is actual medical devices, not including all health technology, of course, but just a picture of that, is increasing and of course much larger. So this was a real concern of the FDA. They already had what we call pediatric device consortiums, which is direct funding for US-based pediatric health technologies and medical devices specifically. But they aim to change this. And so we still have a lot of work to do, but starting to change it a little. Of course, there's all these unique challenges, and this is just a small sampling of that. But people specifically talk about, oh, pediatrics is too hard. But the first thing they always say is there's too small of a market. And I reject that absolutely because of what I said before. I think that there absolutely is a market in some circumstances, and probably most circumstances. You might need to find people who are more likely to turn up the impact dial and turn down, but not off, the investment or ROI dial as well. But there's still definitely money to be made, and we've proven and shown that it can happen. There's also engineering constraints. So you're dealing with a population who's growing over time. There are subpopulations. They're just smaller, which makes engineering more challenging. And then, of course, we're always worried about discomfort. You know, there's some ethical concerns around, you know, harming children or what that looks like, and their inability to self-advocate or vote. And then, of course, for regulatory constraints, this is more of a perceived risk that we see. I hear it a lot that there's this burden of FDA approval and those types of things, but they're actually incredibly collaborative and very, very interested in promoting pediatric activities and truly do, we say, put your money where your mouth is, but they say that, but they also back it up with financial resources. So this is just one thing I wanted you guys to see. This is kind of the state prior to one company that we developed around what is going on with adult central line management. So you put a central catheter through the skin, and this goes into the central blood supply. So it's very at risk for infection. But as you can see, adult central line management is protective. That's a standard tape and standard materials that are developed by a company. They have a quality system around that, and it's simple. But for neonatal central line development, these go through the umbilical cord, and it's a desiccating umbilical cord, so you can't use the other potential solutions. You essentially have an art project. This is just tape that people put together, and that is what secures those lines. They also have the highest rates of infection of any central line. So this is what we're doing for our most vulnerable patients pretty routinely around the world until we developed a really simple solution. And so this isn't so much to show you the solution, but it's to say there was a really significant problem with a really significant impact. And one of our groups that I happen to have been a part of was able to develop a silicone capsule. So it's called Life Bubble, to secure the catheter. And that allowed for decreased migration. And so we didn't just do it once, but we've done it multiple times to prove that this really can work. So with the first company, of course, it becomes a company because that's one of the main ways you have to directly translate to health technologies. Novonate raised only $1 million and then was commercially available. We tend to stay in the academic system a little bit longer, utilize all those resources, utilize non-dilutive grants. But we also wanted to prove that these were venture capital backed companies that could lead to acquisitions. One company that I personally co-founded was called Emmy, and it was really about managing life on birth control pills. It was a hardware software combination, still is available, but we raised 3.5 million and sold that in 2022. And of course, selling these for modest amounts, but because we didn't go out and raise tens of millions or hundreds of millions of dollars, they really were attractive to acquirers. And then there was another company that was acquired by Apple that simplified and did asthma home monitoring, measuring symptoms, and then also simplifying that for children. So these are always focused on children and specifically designed for them. And so we continue to do this over again. We have a model where we're able to, within the academic facility and within Stanford Biodesign, really focus on peds and maternal health. And this is my amazing team. We have amazing fellows. A lot of people stick around for a second year of fellowship. They're also accomplished. They all have PhDs or MDs. And then we have some people through the Gates Foundation, like Nathaniel, George, and Mohit, who have gone back to their home country, that be Nigeria or India, to actually do a lot of work in low to middle income countries to try to develop health technology specific for those populations. And we have people working on anything from pharmaceuticals to medical devices to also including digital health solutions as well. But so we do our own projects and we spin out our own companies, but then we also, for no cost to anyone, support other projects. And we do that through some of our grants. We've helped over 150 companies by this point, mostly focused in the pediatric area, but we did want to expand that. And so we've raised philanthropic support because our FDA grant only allows us to do pediatric in the US, but we're able to support projects and help provide advice and different services for pediatric fetal, which in the US that's not considered maternal or pediatric. And then also we just broke out neonatal, probably because I'm a neonatologist too. As you can see, we've helped people from all over the world. We probably need to update that a little bit, but there's definitely been a team from Finland as well, and at all developmental stages too. Over the past couple of years, we've been able to provide coaching to a bunch of teams, introduction to KOLs and consultants, direct funding, but mostly we're happy that those companies, even though they're early stage, have really treated over 78,000 patients, have raised another 234 million on their own, created full-time jobs, and even exited a bit. So some of those things, and I'll just give you a quick overview of a couple of things we're personally working on. So this is one run by Dr. Kuhn Scheth. She's a pediatric urologist that's part of our team. And this is really addressing fetal shunts. So while the baby is still within mom, there's a bladder outlet obstruction. And what tends to happen is you put in a shunt through the placenta, well, you don't go through the placenta, you go through, you're going straight into the baby, into the bladder, and then you put that in to help drain the fluid from there. And this can have implications on their lung development, et cetera. But those shunts come out quite frequently. 50 to 80% need replacement. And so they are in animal models right now, but have developed a shunt to actually deal with this that has decreased dislodgement and have been able to raise a lot of compassionate capital around this, along with tremendous grant support as well. One of my prime project is called Exhalos. It's a breath monitoring for identifying necrotizing enterocolitis over 2 days in advance. And this is a severe disease that causes bowel injury or death for newborns. And so we've been able to do this. We're still within the university, but have been able to raise significant capital through several different grant mechanisms and supportive mechanisms as well. So if you want to learn more, we just launched a podcast like every millennial does, I suppose. But we're talking to different innovators around the world, really focusing on pediatric and maternal health, but especially pediatrics, and how we actually get it done and how we're actually able to innovate in this space. So tune into that wherever you listen to your podcast. We're on LinkedIn. And then we also have a newsletter highlighting some of the companies that we're working with, highlighting our team, and in general, talking about different issues that pediatric innovators face. So if you want to learn more, feel free to reach out. I know some of you have already reached out on LinkedIn, and happy to chat further in any way, shape, or form. Of course, this was a very brief overview and mostly just a teaser. So, so grateful to be here.
And our next speaker is a fellow from the alumni from the Biodesign Finland program, from Sakari Nikinmaa, from CEO from Koite Health. Sakari.
Hello, hello. Hello, Janine. How do you pronounce Janine?
Yes, Janine Furch.
Yeah, nice to meet you.
Nice to meet you. I'll just go off video so you have the stage and I'm not on a big screen or something.
You're all fine. Okay, hello everyone. My name is Sakari Nikinmaa. I'm a CEO of Koite Health. And today I'm going to tell you about my journey from Helsinki Children's Hospital to improvement of oral health. So like Janine, I was a Biodesign Innovation Fellow 2016, where me and my team went to the Children's Hospital and observed all different needs, different topics we could improve. And I fully agree with Janine that there is a lot of things what we can do better. A lot of applications they use in Children's Hospital are not really made for children. I won't spend much time to this, but this was the process we also did. So we found different needs. We made concepts from those. We innovated different ideas how we could solve. And eventually we got to the phase where we wanted to do a strategy, how to build a business out of this need. But for me, the most important thing was meeting my co-founder, good friend of mine, Tommi Pätilä, who still works as a heart surgeon in Helsinki University Hospital, HUS. And through him, I got the in-depth contact with what it is actually to be a clinician and what type of problems arise in a hospital setting. And what Tommi told me at the time, that actually he operates a lot of different diseases, like heart infections, which have an oral origin, so bacteria entering bloodstream through oral infection and causing infection in the heart. And this is also affecting children, not only just adults. And what is the underlying problem with the development of oral diseases? It's bacteria. So bacteria build up on surface of the teeth and gum line and cause local infections. They are asymptomatic, you don't see them, but when you give them time to build up, they will start infection of the gum and also produce acids, which will then start solubilize the enamel as well as denting, eventually entering to the root canal of the teeth, causing a direct exposure bacteria to blood. And the surprising thing or worrying thing is that 1 of the 5 children have a so-called virulent Streptococcus mutans strain, which causes them to have high risk of dental decay, so caries, and have a poor treatment response to traditional caries prevention and treatment methods. This means that these bacteria, they have ability to attach themselves to surface of the teeth so well that you really cannot remove them by toothbrush. And then they will start building the disease forward once, like every time you eat sugary diet. And with the children, you can see in the bottom right corner, we have this issue called rampant caries, meaning that some of the children develop so severe caries, it affects pretty much all of their teeth. And then that causes dentists and doctors a big problem, how we can treat these persons who have a ongoing bacteria infection in the mouth. And this was actually the solution we came up with. So we wanted to provide an antibacterial method where we can target that dental plaque or bacteria which is left on the surface of the tooth after brushing the teeth and flossing. But if you have something which is really strong in terms of antibacterial strength, then we need to be specific. We cannot treat the whole mouth. We need to focus the treatment to the surface of the teeth and gum line, because otherwise we would sterilize the good normal bacteria flora in the mouth. And this is the device we invented. So there is a oral rinse, which is inert, non-antibacterial, but when we activate that with the light, it provides a strong antibacterial effect through heat, release, as well as reactive oxygen. And this effect then eliminates the bacteria from the surface of the teeth and gum line and enhances the oral health to completely new level without disrupting the normal good bacteria flora. The patented method we came up with in our research was to use 2 different wavelengths of light with this indocyanine green active substance. So the substance itself attaches to the surface of the bacteria, but it doesn't do anything. But when we activate that with the red light, it provides a local release of heat and reactive oxygen, which destabilizes the cell wall structures. And at the same time, we target the bacteria internal molecules with the antibacterial blue light. The method is easy to use. We wanted to make it home usable, so you can administer the frequency needed for children as well as adults to actually provide a long-lasting, robust oral health effect. So you rinse your mouth about 60 seconds, then you activate the oral rinse for 10 minutes, and then you brush away all of that dead bacteria from the surface of the teeth and gum line. And like every biodesign fellow who has been in the program, the biggest dream is that you develop something you can start giving back to community and actually helping those patients you have observed when you were at the hospital looking at what you could improve. And for us, one of these events was with the collaboration with the Union 45, which is a dental clinic in Helsinki specialized in dental treatment under anesthesia. And there they have a lot of child patients who have so many cavities that you cannot really operate them in normal setting because that would be too traumatic for the children. So they are put under anesthesia and then they don't remember or feel the heavy dental work which is done to them because of the maybe a lot of cavities they have at the time. And how Lumora fits to this protocol is after they have fixed all of these cavities, then there might be some cavities which are just in the development stage. We can inactivate those with this antibacterial method. Another study we have now ongoing with the Helsinki University Hospital is focused on the cleft lip and cleft palate patients. And usually these problems are fixed in the early childhood around the inside of the mouth, but during your age of 9 to 12 years old, the gums are fixed. And there is a part of bone which is taken from the clavicle and put into the to the gums to kind of create the bone where you can place implants to give a proper smile for these kids. And it has shown that local antibacterial therapy during this treatment can enhance the effect of long-term patient survival or the long-term treatment effect. So for us, it's important to study how well we can improve this. Then, of course, we have a lot of other things going. So we are not only focusing on the children, but also adults. And we are running now about 15 clinical studies in different topics. But in this topic, I wanted to highlight the ones we have with the children. And also, like we say, that children cannot use always the adult mouthpieces, adult sizes. So we wanted to develop them their own kit they can use. And this kit is for children up to 4 years old. And the main focus for this is to prevent caries or dental decay. And I fully agree with Janine that with children, the prevention is essential. They have long lives ahead. So we don't want to do invasive treatments. We want to prevent diseases and upkeep the health. The patient, what I observed in Helsinki Hospital, the patient commitment towards treatment is 100%. So they will do whatever they are needed to get better. So I think that was super motivating. Many solutions I saw there weren't optimal for children, wrong size, clumsy, not pretty much designed for adults. So the doctors needed to do different innovations to try to adapt and make the kind of different protocols to adapt existing treatments for children. The market is generally smaller, not always, but many of the children, the health issues they face with children are quite rare, especially relating to birth deficits happening, for example, heart surgery. So there is a problem in there. And that population is highly regulated. Specific clinical studies are usually needed for market approvals, and the ethical standards are stricter compared to the adult population. So that's also for us that we have a specific child studies also running, as we want to demonstrate the effect also in the pediatric population. Thank you.
Thank you, Sakari. So next up, we have Mikko Kytö, Development Manager from Helsinki University Hospital.
Okay, thank you, Otto. Yeah, my name is Mikko Kytö, and I'm presenting one of the examples of Clever Health Network project what Katarina explained in the previous session. So my project, or our project, has dealt with gestational diabetes. So it's a diabetes that develops during pregnancy, and this project has been done together with Fujitsu, Elisa, Aalto University, and University of Helsinki. And we at the HUS have been the research partner in this project. So why it's important to treat gestational diabetes? It's very common due to the increased number of obesity. So there are approximately 20% of pregnant women receive this gestational diabetes diagnosis. So it's affecting a lot of pregnant women and the next generation. And this TDM, in fact, actually imposes type 2 diabetes, so increases the risk of getting type 2 diabetes 10 times compared to without the diagnosis. And the metabolic risks are also significant in the next generation. So this is really important to manage well. The challenge that we aim to solve is that the monitoring of women with gestational diabetes is not sufficient. So the women with gestational diabetes take this fingertip measurement once a day or sometimes a couple of times a day. And this doesn't provide the full picture of the glucose levels. And also the information that is given to women with gestational diabetes are dated, so they are pretty much the same information, general leaflets and that kind of very general information. Our approach is to make these things visible so that the women with gestational diabetes can follow their glucose together with their lifestyle in real time. So this provides continuous information about the blood glucose levels also during the night times. And also they are able to monitor their weight and during the pregnancy. And also we can measure the weight and body composition of newborn. So typically the women with gestational diabetes give birth like very large babies, so we can reduce the number of macrosomic babies with our approach. So this is the basic concept of our approach. So we have a pregnant woman who is using these devices, and they can see the information through the mobile phone screen. And the same information is shared with the healthcare professional and researchers in real time. So the service concept is easy-to-use mobile application that combines all this information into a single view. And the main idea here is that all this learning that the mother needs to do, how to manage the glucose levels, is made by themselves. So they don't get any extra guidance or feedback about their glucose levels. So everything that they learn, they learn from the data that they collect themselves. And we did quite a lot of desk research on the topic. So there are a lot of qualitative studies on gestational diabetes that we first looked at. Then we engaged the women with gestational diabetes to use these different sensors. We tested multiple types of wearable sensors and their apps, what they like, what they wear most, and so on. Then we prototype different kinds of features to the application and ask feedback from the becoming mothers. And then finally, we did this minimum viable product that we evaluated in this randomized control trial in order to evaluate its effectiveness to manage gestational diabetes. This is how the app looks in practice. So the person is wearing this continuous glucose monitor and is keeping a food diary. First, we actually had this speech-enabled food diary, but the world wasn't ready for that. But now with the improved natural language processing, I think this would be again a good solution to try out. Then the participants used this activity bracelet, and they also measured their weight. And all this data was visible in the app so that the mothers were able to view their data on a weekly basis, a daily basis, or even hourly basis. And they were able to see how their different nutritional facts about their meals in a very detailed manner. And there was also information section about the gestational diabetes and pregnancy and the fetus. So in this randomized controlled trial, we did this in a very in a classical way. We did baseline measurements for women with gestational weeks from 24 to 28. And they were randomly assigned to intervention group that used our application 1 week a month, and in addition to standard care, versus a control group received only the standard care. Then at the later stage of pregnancy, we did measurements, and at the birth, we did more measurements, and we also had a follow-up study at 3 months postpartum. And in order to make an objective comparison between the groups, we used multiple sensors. This first beat lifestyle sensor, and then the physical activity sensor from UKK Institute. This was also a bit of gauge or handle the Hawthorne effect, so that both groups were observed in the study. And the principal findings were very good. So we found that this was actually effective, and this was the first periodic digital intervention that was shown to be effective without the feedback from healthcare personnel. So the women with gestational diabetes really learned how to manage the gestational diabetes and what kind of relations there are between their lifestyle and the glucose levels. So the participants had lower glucose levels, they increased their vegetable intake, improved physical activity, had lower gestational weight gain, and there was reduced rate of macrosomia. So there were less babies weighing over 4 kilos in the active group. And what's important is that these improved clinical outcomes correlated with the usage of eMom. So the more they used the eMom application, the better the clinical results we were able to see. And the eMom, what was the role? It was that they really empowered the women to manage the GDM effectively. And this was actually a learning process, so that we actually have another publication coming out of this, but it was really about learning, not motivation. The motivation to treat GDM was very high in both groups, so the mothers were motivated because of the sake of their child. And what differentiates these results from the existing results, that there was no guidance from healthcare personnel, and it was all visible in one app, and we used this periodic approach. And in the future, we aim to develop also AI-based suggestions, because we try to make this application accessible for all the persons, so that you don't need so many good data literacy skills and kind of health literacy skills to learn from your data. So the AI recommendations are like shortcuts for mothers, like eat like 2 potatoes instead of 3 potatoes, or any kind of this kind of very concrete and personalized suggestions would be the key. So we are here now at the second generation, and we try to come up with artificial-based predictions and such recommendations for the mothers. And there's some work on this, as seen from the image. Again, this three-handed woman appeared here for the from the AI. So there are some rules to really consider here, how to create these predictions. One example of AI study that we did is that we investigated how we can use the data from healthy group to fulfill or make additional information for the data modeling, so that the typically pregnant women don't have much high intensity physical activity. So it's very difficult to predict what are the glucose levels after the high intensity physical activity. But then we get this data from healthy group, and we can transfer the learning to our case. And we were actually able to improve the glucose levels predictions when we added this data from the healthy user group. So sum up the benefits of our solution. So we have really improved the clinical outcomes, and this real-time information is really key for mothers to learn from the data. And this data also provides opportunities to make these personalized predictions and recommendations to support behavioral change. And this is also a scalable solution. So one can think of applying this in this, for example, for persons who receive type 2 diagnosis. They might, in the first stage, they might need some support in the learning how to deal with the diabetes. So this might be a good tool for them in the, at least immediately after their diagnosis. And we are planning to do a continuation study in maternity clinics. So we want to study this in real context, and we, for example, our participants were quite highly educated. We want to investigate in this other contexts, and also we try to investigate how this fits into the whole treatment path from primary care to special care, and what's the impact of this solution on healthcare personnel's workload. Thank you.
Thank you, Mikko. And now actually is the time for the panel discussion. Let's see how it goes with the technically. So we'll do our best. Oh, sorry. It's been a long day. So very sorry. So next up is Aura Pyykkönen. She came in the last minute. But very warm welcome. Very important project. A Natal Mind. It's been also from the body sound related project. So please tell about the project.
Thank you. Pleased to be here. Yeah, that looks about right. Okay, so very excited to be on stage. I'm talking about birth. Everybody's been there. All of us were born. Some of us are parents. Personally, I'm a mother of 3. Also, I'm an obstetrician and gynecologist, and I hold a PhD in quality assessment of obstetric care. And with Natal Mind, we approach birth with the psychological intervention. And birth is where mind and body connection becomes very tangible. And we want to increase both of these individuals with resilience and trust, and improve the whole process for them. And coming from the country with a renowned maternity care, we believe we are able to do this. The problem is the broken maternity care. Women and men alike are left alone during the process of becoming a parent. The lack of continuous support, the lack of holistic care is contributing to a whole load of problems. This is a very vivid problem in the labor room. I can see this as a prolonged labor. I can see it also as increased intervention rates, cesarean sections. Most importantly, it's contributing to the health and well-being of the families in the long run. And going back to the very first talk today, Janine started off, this is where we can have an impact. If we look at the rest of the life, this is where we can have an impact on the person that is not even born yet. And this is also where the cost comes from. Nearly 50 billion are the annualized lifetime cost in the US alone. And this is counting in the cost costed by the offspring. So what we do is we've developed an app, a mobile application, providing a digital doula, a therapist, and a midwife on your phone. She's AI-based, so she speaks whatever language. She can look whatever you want her to look like. She's non-judgmental, she's personalized. But the information she delivers is rooting to our system and rooting to the best practices that we've shown that work, and we've gathered them and we've made them into a scalable version. Emotions are at the heart of our solution. We've enhanced an emotion tracking algorithm developed here at Aalto, and we use it in a dual way. We use it to serve, at the moment, mass customized rehearsals for the user, but while doing that, we're also collecting a highly valuable data set of the emotions. Pregnancy brain is actually a thing. It's not hysterical, it's a thing. We just learned from Nature a couple of weeks back that the volume of the gray matter is actually literally decreasing. The brain is melting. We don't know why evolution made it that way. The hypothesis is that it enables new neural connections in the brain, in the mummy brain. But we see that gathering this emotional data from this very, very sensitive period is a massive asset for us as well, and will enable us to develop a predict and prevent tool for perinatal mental health problems. What we're operating on at the moment is a research to business grant, and with that we've been able to develop a fully functioning minimum viable product. And with that, we ran a clinical trial here in Finland with 200 women. What really warms my heart and gets me really excited is the cesarean section rate. So whereas in the control group, the cesarean section rate is 20%, we see a 25% reduction in the test group. Our main outcome is the childbirth experience. I don't yet have results of that, but we're also targeting the fear of childbirth, which is a predictor for mental health problems postpartum. And what we see in the control group is that the fear increases when the birth is approaching, and this is what happened in the population in general, and whereas in the treatment group, it even decreases a tiny bit. These are not statistically significant yet. We haven't analyzed the whole data set yet. We don't even have the whole data set yet. What we're doing next, we're doing the trial again with our partners in South Africa, and there we can gain more diversity, we can gain more population, more women giving birth. Here is our champion in South Africa, Anusha Laman, the president of the National Psychiatrists Association in South Africa. And with her colleagues, including Lavinia Lumu, president of the International Marseille Society for Perinatal Mental Health, we've set up a clinical trial to start off Q2 next year. And with that, we can show that this solution works outside of Finland as well. The problem is global, and naturally, the emerging markets are where the concept of perinatal mental health is not really even recognized that well yet, and there is there's more of a potential for a digital solution to penetrate that market. The value the beneficiaries are the whole of society. And this is also going back to the Chinese first talk today around that it has to be a viable business and it has to have a payer and it has to have a solid payer. And here we see that once we have the clinical data in place and we can show that it works also outside of Finland, I'm sure that the insurance companies and employers alike are willing and interested in sharing the bill. This is our team. It's me, and I'm an obstetrician and gynecologist, as said, and we work together with Riikka Lemmettyinen, our psychologist in the team. We have Saranya Ramakrishnan, a very experienced health tech professional, and then running our tech, Mikael Högqvist, also background in health tech, and then Annika behind the fabulous design and our product development. So this is us in short. Happy to discuss more and happy now to join, I hope, the panel discussion. And yeah, let's see what we can talk about.
Thank you, Aura. And let's have a seat here. Maybe I'll just move them a little bit closer. Real innovation here with the technology. Okay, let's see how it goes. So we are all crowded around the computer. So let's see.
I hate that you're doing that, but I also can see part of me on the big screen, which is always frightening to think about how big my head is.
It's very big.
Yeah.
I also appreciate you being up so early.
Yeah.
Yeah.
Happy
to be here.
Very good. So you hear us, we hear you. So let's start by asking the same question for all the panelists. Maybe we can start with you, Janine. So what do you think are the main barriers for implementing healthcare technology in pediatric settings?
Oh, I could talk about this for a very long time.
Yeah.
So I will speak specifically from the US context, but I know that has a lot of downstream implications. And I only minorly touched on this. I think you're right on nailing the nail right on the head when you talk about what's the implementation issues. I think that there's need issues where people ask much smaller questions in a smaller population with a smaller impact, and that doesn't work. In pediatrics, you have to ask questions that have a bigger impact, that truly are able to drive a field forward. So it starts there. But on the implementation side, we have, a very broken healthcare system in the US, which of course I know trickles down everywhere else. And we're often jealous of other people's healthcare systems, such as yours. However, there's something that always goes through that. So we don't have a healthcare system that is set up that rewards preventive care, that rewards healthy life, that rewards any of that. So I think the biggest problem right now is that children don't vote, but older individuals do. And so that drives everything from there. it drives reimbursement. When people talk to you about reimbursement, they say, oh, we'll just get the Medicare code. Well, if you know about the US healthcare system, Medicare is only for people above age 65 and some very specific conditions. Well, no pregnant mother or child is above 65. So that leaves you in this very weird area of how do you get reimbursed? Where do these things fall? 50% of children are under Medicaid, which is our government-based insurance, which reimburses at 50% the rate of Medicare, the older people insurance, which is a real problem. And so there's policy changes that need to occur. And, my team and many, many others are working to make those policy changes. But that's probably the hardest part when it comes to implementation, is truly that there's structural things in place that don't allow you to be able to implement and understand the implementation process in a way that's interesting. I will give a caveat because I always like to be a realist about this too, and give a little bit of optimism. The really good part about it though is you don't just capture a small part of the market. If you're a solution in pediatrics and there's nothing else out there and nobody else has FDA approval or no one else has any sort of clearance, then you can actually capture the entire market, which leads to a much larger market penetration. And the numbers are, there is reimbursement there for that. And there's a lot less children's hospitals, and they tend to work together better than adult hospitals, and pediatric providers tend to be more engaged. So I do think that there's a lot to be hopeful for, even though there are a lot of challenges.
Thank you. And maybe Sakari, I know that you have to leave in a few minutes, so maybe you can tell a little bit about the challenges you have seen.
Maybe for me, I think the most important, as an engineer, biomedical engineer as a background, I tend to look at things quite direct. And of course, it's the regulatory aspect of doing and the higher needs for kind of ethics committee and the stricter ethics committee are also something you have to keep in the mind. The other side of things is basically the doctors in pediatric side are more connected, especially in the subgroups like heart surgery. They are all connected with each other. So if you make an innovation in the space, it's pretty much you go to few meetings and you have the full globe, all the professionals know about your invention. So in that side, it can be better, but also in the kind of the regulatory aspect, I think for me is the kind of biggest limitation in that kind of access in the market.
We can help you with that one in the US if you want.
That would be great. Right. He will contact you later. Yeah, good. Okay, Mikko, would you have something to say about what have been the kind of challenges you have seen in your project in this kind of population of the mothers?
Yeah, I mean the population has been really great. They have been all very enthusiastic about our research. I think the challenges have emerged other places. The joint development with the companies required quite a lot of work to get things started, contracts and that kind of things. And now at this stage where we aim to pilot this in maternity clinics, the financial situation is really the challenge, really the biggest challenge, that we would need money to implement the pilots, and that's challenging currently.
I'd say matching the how would I say, the user and the payer, or the problem and the beneficiary. Because in our case, for example, what I'm talking about, I'm not talking about pediatrics, although we have an impact on the baby being born, but I'm talking about maternity care, and that is that the mothers and the couples themselves are very willing to invest in their well-being and health, but it's still, since the biggest beneficiary of dealing with the problem is the society, and we should find sort of a bigger player there to pay for these solutions. But that would require us to have the right measurements and right indicators in place. And going back to the first comment again, that we are not equipped yet for preventative care, and we don't have the measurements where we can sort of measure not developing an illness, and this is the major problem, I think, when you're actually trying to create something that is truly preventative. That how do you prove it and how do you show it, and this is where I'm super excited about finding something like a cesarean section, which is very binary, which is very, you either have one or you don't, and that's if you can show something like that, even though it's not directly towards what we are doing towards improving the maternal mental health, it's still part of the journey, and that is something that everybody can understand. So finding those indicators and finding the right things to measure, I think, is a key to finding a viable business and finding a viable solution.
Thank you very much. I think Sakari, are you still ready for one more question? Okay, good. So let's, Sakari, you can start the next one. So how do you think you balance that kind of like innovation and also then giving like affordable, equal like access to healthcare? Because you would think that when you innovate something new, it will be quite cost prohibitive. So how do you make it sure that like you can innovate but still keep it like accessible?
I think that's the kind of main focus of engineering, in a way, that when you develop a solution, at least for me, the biggest focus has always been to do something which works, and then after that you start thinking how I can administer this in a most cost-effective manner. But of course, the first has to be that I want to make something which works, and then you start figure out what is the best way to give it this type of treatment. And like in the before, we said that in a prevention. Actually, now that I think about the last question, is that actually the issue is not. It's actually in the prevention, that we don't focus in prevention. We focus in treatments. And children, they pretty much are healthy, and then they might get some issues we want to prevent. And kind of the aspect of, if you want to focus in prevention, usually the money is not there initially, so you then need to kind of, usually people might in the start have to pay from out of the pocket themselves from the preventative solutions. So if you focus in that space, then you have to be really careful how you accumulate cost into your approach and solution you're going to offer to the customers. And I think the digital solutions are quite nice in a way that they don't have any, the bill of material is quite cheap for giving the treatment. So then I think those are excellent preventative solutions you can offer.
And maybe Mikko, you would like to continue on that?
Yeah, in our case, we didn't focus on preventive care in the sense that it's very important there are preventive actions that avoid the incidence of gestational diabetes, and there are some very effective interventions on that. But on the other hand, there are still going to be people who will actually have the GDM diagnosis. So it's very important to treat that as good as we can.
Yeah, I want to second the first one, that the money is not there, and then we have to first have the users to pay for it before we can actually show that there is an impact. And then going to what you said about GDM, about gestational diabetes, as a sort of like considering that as an end outcome. But I would consider that sort of like, since we're having, I don't even dare to say out loud how big a proportion of the parturient women are actually diagnosed with gestational diabetes with the current criteria. But I think that's just the beginning. That's when we start actually, if we can improve the treatment, that's already prevention, because we're preventing the secondary sort of problems and outcomes from there, part of which are actually mental health problems. So it's kind of, I think, also there's a lot of synergy with what we do, and I think that we should sort of think that it's not just one outcome that we need to focus on, and see the whole bigger picture, and also how you, Sakari, mentioned that the infections are also contributing to gestational diabetes. And so it's kind of like having that holistic view and seeing the problems not in silos.
What about you, Janine? What do you think about how you balance this innovative new products with kind of this accessibility reasons?
Yeah, I think I might flip that on its head from a little bit of what was said before. I definitely agree, but I would actually think about it early on. So work that we've been trying to do around health equity and other things, making sure that we really address all populations, or at least know what populations we're addressing or not addressing, can be really important. So we actually sometimes put it in our need criteria if we're talking about real process-based things. So this was really early on. For an example, with Emmy, the birth control app and hardware, we wanted to make sure that everybody had something that was accessible. And you're talking about a lot of things that are considered direct to consumer. So if you're talking about the consumer paying for it, then it becomes a little bit more challenging. But if you can show the impact, if it's the system and the healthcare system paying for it, then that's different. So we have to separate those two. When we went to Emmy, we actually said, okay, we know apps don't work that well, and we need this hardware attached. Let's, for the very first thing, we have to build this app anyhow. We'll charge for the hardware and we won't charge for the app. And so we'll make that universally acceptable to everyone. And it's better than nothing. And we think it's better than the apps that are out there, but it's probably not as good as what we have. Now, I don't like that, building products that are not as good for other populations. But that was our first step. And then always with the eye of saying, okay, now we can get it covered by insurance. We will move in that direction, not just because it's good for the business, but because it's good for humanity. And that's what we actually want to make sure that we're doing. So thinking about those things really early on and often, even before you've built a product. And the one other thing I'll say is sometimes when we think about, well, let's engineer it and then figure out the cogs, you certainly have to do that. But even before you engineer something, remember the simplest solution that actually meets the need always wins. So don't over tech it, don't over design it, don't overdo it. Try to keep it as simple as possible while also still meeting your need, meeting your end goals, and those types.
And continuing that on, like, how do you kind of work with the kind of your patient populations? How do you engage with them? How do you kind of, are they part of the innovation process, of the development process? Let's start with Aura first. Like, how are the mothers, your kind of patients, part of your development?
Well, this is also originated in biodesign program. So it's very much, they are very much at the core and the very focus of it. So Annika started off by in an immersion period in the maternity and child health clinics, which account for about 99% of all pregnant women, and then also where I used to work at the biggest birth unit in Helsinki. So very much, to put it short, like the need comes from them, and that there needs to be something. And also what we did during the process of what we're doing now is that our team interviewed about 30 professionals globally, and the message from them was that there are no people. So healthcare professionals, especially therapists, they are scarce everywhere. So we need scalable solutions, and we need to sort of emphasize that important human interaction and give as much value to that as possible by taking off some load that can be digitalized. So we're not saying that everything can be digitalized, but we can take some of the burden and the load off.
Yeah, in the EMAN project, we engaged women with gestational diabetes at various stages by interviewing them and with different kind of questionnaires on usability and motivation. And we were happy. We were like able to do iterations with this classical user-centered design cycle with the women with gestational diabetes. So it's very important part to make this success.
although I was in the biodesign project, our focus wasn't really, it was a patient-centric, but it was also technology-centric. So we found out that there is this photothermal, photodynamic effect, which is quite unique antibacterial method. And then we had different conditions we could treat with this solution, ranging from wound care to oral care, etc. And then actually the focus where we wanted to target the oral care was through systemic health effect and how common the oral diseases are at the moment. So it was more like in a market perspective and the global needs perspective. We felt that this is something we want to make a big impact on.
And Janine, can you elaborate on like how do you work with your patient groups?
Sure. It is the fundamental part of everything we do. We can't possibly be able to deliver solutions to patients if we're not involving them from the very beginning. You know, like was previously mentioned, obviously it's the observation straight from the front, but also then thinking through, we've had many focus groups to understand the need and then vet the potential prototypes and technologies, and they've directed us in a variety of ways. I have so many stories about how they've completely changed what our solution would be, giving us insights that we never would have been able to experience ourselves, and really help direct a development right from the beginning and right from understanding the need. Sometimes my fellows are always, you know, initially in the beginning of the year, especially the physicians are guilty of this. And I'm allowed to say that because I'm a physician, I guess, but they always want to make things to improve the physician's workflow, lifestyle, like experience. And those things always end up falling to the bottom of the pile and fall flat, because unless they also and primarily actually, in the US specifically, nobody really cares about what the physician's experience is. We care about what the patient impact is and what the patient outcomes are. So, and that's where it should be. We should care a little bit more about physicians than we do in the US, but you know, I still think that's in the right spot. So think about innovating for that patient from the very beginning and you won't go wrong.
Okay, thank you. And I think I have one more question, then we can open the floor for one or two questions from the audience. So this was already asked today from another panel, but I thought that I can take the same question and spin it for you as well. So how do you see your work in the future, let's say 5-10 years from now? How do you see kind of new technologies like artificial intelligence and different kind of like digital tools, how they are kind of impact not only the solutions, but the way you work and the way you innovate? Do you see there's an impact with this kind of like a new things that we are seeing at the market and developing fast? Yeah.
Well, I think the self-care will increase with the aid of AI. That will be definitely the case. There are many drivers: lack of healthcare personnel, lack of money. All these go to drive the development to the same direction, increase self-care and maybe remote care or remote monitoring as well. Regarding our work, I think that challenges might become more difficult actually in the future, because there will be, well, the tools will be better, but the problems will be more complicated.
I'm hoping that physicians will become less, how would I say, change resistant. I think, well, yeah, I can say that because I'm a physician myself, but I feel that it's these self-monitoring tools are, I think, the least accepted by the physicians, and they are adopted by the patients. They improve the patients' lives, and then when 20 years ago when the patients came in with their step counts or whatever, and doctors went like, what is that, and don't show me that kind of thing, and I think there will be a huge improvement there, and I think it will be very different profession to practice as a physician. in 10 years. I hope it will be very different, and I'm sure the self-care, the preventative care, and the more personalized care will be there. That's I think a safe thing to say now.
And what about Janine? What do you think, where we're going to be in the future? What is your thoughts on this?
Yeah, I completely agree. I mean, I think that all change is good change, and we need to change as a field in general. We need to get up to the standard of where, you know, dropping your dog off at doggy daycare is. I mean, like, they know more about their dog and what's going on during that day than you know, and your child in surgery or your child in the hospital or scheduling. I mean, there's so many different things that need to change, but fundamentally humans are still a part of and the core of the healthcare system. So while that may accelerate some of our workflow, sometimes we find it complicates our workflow. Certainly, like medical records, especially in the US, have done, and make things worse in a variety of ways, while also making some things better. I think we have to be really mindful that these may accelerate our technologies, these may accelerate our advancements, but also there still has to be a human in the middle of it, and we have to be able to double check things, make sure that they're, frankly, in a lot of these AI algorithms, there's very few that have children involved. So you're actually not understanding what's going on with children. And so our advocacy is going to be even more important in those ways. Again, can talk about this for a very long time. I really do hope it's a better world, but we need to be active participants to make that happen. In terms of actually finding needs and vetting needs and doing that, there's this new technology called Sleuths AI that actually takes the biodesign process. It's a former fellow. I don't know if you guys have heard about it. It's we have early access to it, but it'll be coming out. But it actually helps you create need statements and vet them, and it's pretty interesting. It's great, and our fellows are using it. But we find that you also need to understand the process too, to be able to help work with it. And I think that's the part where we can't miss. You still need to understand things at a fundamental level.
Thank you so much. And I think we have a room for one audience question. Then we have to announce who is going to win the pitching competition. So
very
Patrick.
good. So thank you, distinguished panel. So let's have one question from the audience, please. You have a fantastic opportunity here. Someone has to ask a question. You can't go until you do. Yes, come on. Let's have a question.
Riachi, you have a question? Yeah?
Well volunteered.
Well, rather a comment. Okay, so now we are suffering from the decline in our population, and the birth rate is critically going down. Yeah, but still, people focus on helping older people, and I totally agree with what you guys told us. And we need to focus on, the human race to survive. We need children, and the support. And we have a lot of technology and all these stuff, to estimate what's going to happen, and of course, to have an ease in raising children and giving birth to children, technology needs to be focused on this side. And yeah, I'm grateful to what you guys just presented. But the question is, okay, who's going to support this? Where does the money come from? Who would like to pay? And this is a question, and we all need to think about. Thank you.
Thank you. Panel.
So Janine, did you hear the question?
I couldn't hear it very well.
Okay, so I will just repeat it. So basically the question is that as there is kind of declining birth rates, there's still emphasis on providing solutions for more towards, let's say, elder care, and maybe not enough emphasis on young families and raising children and supporting this kind of aspects. So what do you have any thoughts on this? What could be done to different support or systems that could have an influence on this topic?
I I mean, from what I understand about the Finnish system, I think you guys need to answer that because we clearly have done a terrible job supporting families, children, mothers. We don't have paid maternity leave. We don't have mandatory paternity leave. We have extreme childcare costs. It is creating smaller families, people working from home. We also have extreme housing costs, unhappier populations, and everything I hear from your country, which I would love to visit someday, is that, you know, there's a rosier picture there. Of course, I'm sure that everything is, you know, with rose-colored glasses from afar, but we have structural problems, like I mentioned before, in the US that really impede our ability to ever have incentives that focus on children because we care about the people who vote. And you know, there's a big election coming up and it matters who vote and they listen to the people who vote. And that's who has a voice in our country. And so it's up to the rest of us to have a voice for the people who don't. But there's things that need to change and there's things that really need to change if we're going to survive as a society. We obviously have to invest in the future and not the last few months of life. It makes absolutely no sense. But it's seen over and over again in our own population, our own decisions and the structure. So that's why we're working from a policy aspect, from a very fundamental aspect to change policies within the US to be able to promote a higher birth rate and more support when those children are born. So you guys know how to do it. We don't.
Yeah, it is a really big political question, and I hope the wisdom for the politicians to make the right decisions. And I actually need to go to get my children out of daycare now, so I need to finish.
So you are putting the primacy to the children.
Yeah,
that's
so
good.
we'll let him go, and I'll stay. And so I love the question, and I love that we're putting emphasis on that one because it's exactly the question that we are asking. It was shown here in a PhD thesis defended about a year ago here in the Helsinki University that a bad birth experience actually decreases the likelihood to have a second child by 25%. So that is at least our contribution. We can improve the childbirth experience and through that improve the number of children in the family. But luckily, the reducing birth rate is pretty much the problem of the Western world. So maybe the global, just the balance is shifting and kids are still born elsewhere. And this is going back to what you just said, Janine, that we've been trying to do quite a bit in terms of doing those social interventions and putting families in the front. We're not doing that great on improving the already very good maternity care. I must say that it's globally it's rather good, but it's something that is happening that is probably beyond what we can do as medicine, as sort of healthcare. It's a global, it's a cultural change. It's a change in the values and fundamental things which are beyond our hands, I think. With the mobile application, I won't be able to save this problem.
Yeah, but with the citizens and like we can have maybe some work together.
Yeah, for sure.
Good.
I can do a tiny bit.
Good. I think that's a very empowering note to end upon. So it's not just about the company, it's not just about the technology, but us, like thinking about how to make this shift happen, to put more emphasis on like families and young children, to keep them like healthy and like giving them a promising future to look forward to. So thanks all for the panel. And now we have, in a few minutes, we'll announce the winners for the pitching competition. So please stay here. So thank you so much.
Thank you.
Thank you for the opportunity.
Let's see. So first, let me introduce to represent the Angel Syndicate, to tell who is the winner for the Angel Syndicate. So Gustav, please come to the stage. Can you please tell a little bit about the decision and why did you like it and what is your idea
to go forward?
Okay, so it was very tough decision. We had very good discussions with other investors, and I must say also that I'm very happy to see that the quality of all these companies today, for example, it was very good and it was very difficult to make a choice. But nevertheless, we needed to have only one winner for the Angel Syndicate, for which company there's a syndicate of 4 angels that are willing to continue with the discussions. And the company had an innovation that really has a clinical need. Time to market is short enough because some of us angel investors, we are not that while risk appetite is not that high, and the competitive situation is very attractive. So it's good for angel investors, and I'm very happy to announce that KiwiCare is the company who is a winner for this angel syndicate.
Please come on stage. Jan, let's take some picture from the center maybe. And maybe Kusta, you can be like, maybe Pratek, you can join as well. Yeah. Go to the middle of the stage. Go to the other side. But the story is not over yet because we still have the VC winners as well. So like let's have Jun from Hadean Ventures to tell a little bit more about that.
So yeah, first of all, I want to thank our companies participating in the pitching event. You did a good job, and we're excited by several cases. And it's again a tough decisions. We discussed, back to front, and we made a decision to have 2 winners for the VCs. So one is filling the gap in diagnostics and cracking the code on a problem that we will most likely face to the later stage of our life. So the company is Otos. Congratulations. And we have a second winner, which is really challenging a paradigm that has been very difficult to treat. And recently we have only a new drug approved in the space, and that's really changing the paradigm, and it's really good to see more companies like this coming up. So the second winner is Polku Therapeutics. Congratulations.
So please join the stage, and also the VCs who are still here, can you still come to the picture as well? Yep.
liikennettä seurata, mitä silloin